If you are converting work into heat, yes, 100% conversion is possible. Suppose one vehicle is moving continuously, it is moving, it is giving some useful output, and if you are putting some brakes, that work which was being done, that work immediately will be converted into heat on the brake shoes, and in equal amount it is possible. But reverse is not true. And many losses are there, many irreversibilities are there when we are converting this heat into work. Even your thermal power plants, where electricity we are generating with the help of coal. So heat source is your coal, work output which you are getting, we are getting on the generators in the form of electricity, that is high grade energy. In the case of thermal power plants, we are heating water in the boilers with the help of coal. That water which has been converted into steam, it is passing over the turbine blades, and finally it is resulting into electrical energy which is through generator. The generator is connected to a turbine. But the conversion, suppose 100 kilojoule heat we have given to boiler with the help of coal, the conversion into useful work may be around 21%, 22%, 23%. So huge losses are there in between. Major reason for not getting 100% efficiency is every heat engine, it has to work in a cycle. If it is not working in a cycle, continuously output we won't be getting. In a boiler, we have given heat, steam has been generated, that steam has passed over the turbine blades. After passing over turbine blades, again that same steam we are supplying to boiler. Then cycle will be completed because water has been heated, it has been converted in the form of steam, it has passed over the turbine blades, finally it came out from the turbine at a lower pressure, again lower pressure, that steam we are supplying back to boiler. So the cycle is getting completed. For completing the cycle, because when it is passing over turbine blades and when it is coming out, it is in the form of steam, and if that same steam we are supplying to boiler, which boiler is at a higher pressure, maybe some 15 bar pressure, 20 bar pressure, 25 bar pressure, but when steam is coming out from the turbine blades, its pressure may be roughly atmospheric pressure or slightly higher than atmospheric. That pressure steam, if you are supplying back to boiler where pressure is higher, after expansion in the turbine, pressure is lower, so if you are supplying back, we'll have to compress it. If you are compressing the steam, whatever amount of work we have obtained over the turbine, same amount of work we'll have to give as an input, and then only that steam will be going back to boiler because boiler pressure is higher. If same steam in the same phase, if you are supplying back, then useful output which we will be getting, that is zero. Means whatever we have got from the turbine, same amount of work we'll have to give to the compressor for the purpose of compression, and then only it will be reaching to boiler. So net output will be zero. So what we are doing, we are changing the phase. After expansion over the turbine blades, we are changing the phase, means steam we are getting converted into liquid, into water again. If you are converting it into water, then heat will have to reject into the surrounding. If you are rejecting the heat to the surrounding, that is wastage of heat. The heat we have given with the help of coal, but for the purpose of heating the water, but for the purpose of condensation, because we are changing the phase and liquid will be compressing, and then it will be supplying to again to the boiler. When we have changed the phase, that time we'll have to reject heat to the surrounding, and that is wastage. So that's why when heat engine is working in a cycle, its efficiency can't be 100%. Suppose 100 kilojoule heat we have given for the purpose of heating, and in condenser for changing the phase from vapor to liquid, some 30 kilojoule heat we have rejected. So effectively the efficiency which we will be getting, that is 70 divided by 100. Output will be 70 because 30 kilojoule we have rejected into the surrounding for the purpose of changing the phase. So efficiency won't be 100%. So in any heat engine, efficiency can't be 100%. If it can be possible only if you are not rejecting the heat to the surrounding. Same is the case of Carnot cycle. Somewhere I'll be discussing Carnot cycle also, which is most efficient, but still it is not 100% efficient, because in the case of Carnot cycle also, we'll have to work in a cycle. If you are working in a cycle, at some point of time we'll have to reject the heat to the surrounding for completing the cycle. So that's why efficiency of even Carnot cycle is not 100%. The unit of heat and work is same. It is joule or kilojoule, like that one. Even in market, suppose someone is selling this heat and work both. Someone is sitting in the market and is selling So 100 kilojoule heat is selling, same time 100 kilojoule of work he is selling. And if we want to purchase, if cost is same, our preference will be at the same cost, 100 kilojoule work and 100 kilojoule heat if it is available, our preference will be to purchase 100 kilojoule work because it is high grade energy. That 100 kilojoule work anytime can be converted into 100 kilojoule heat, but 100 kilojoule heat can't be converted into 100 kilojoule work. So that's why heat is termed as low grade energy, work is high grade energy. So our preference is always to have high grade energy. Even the energy which we are receiving from sun, the solar energy which we are receiving, it's low grade energy. It's low grade energy. The level of grade also increases as temperature is higher. Lower the temperature, grade is lower. Higher the temperature, grade is higher. Sun is at 5000 degrees Celsius. If energy we are getting at 5000 degrees Celsius, heat if you are getting at 5000 degrees Celsius, its level will be higher. If you are getting heat at 40 degrees Celsius from sun at earth, its grade is very, very low, very low. Yes. So if we are converting heat into heat, then it is quite efficient. If you are converting heat into work, then inefficient. If heat is getting converted into heat, suppose solar energy we are utilizing for the purpose of heating the water with the help of solar heater. If you are heating the water, then heat is getting converted into heat only, then it is 100% efficient. But if photovoltaic mechanism we are using, solar energy we are taking and then we are converting it into electrical energy, it won't be 100%. Normally the efficiency which you are getting even in solar photovoltaic, it is 18, 17, 16%. So efficiency is very, very poor. So always our efforts has to be, if we want to use heat, it should be in the form of heat only. Suppose you are having LPG gas cylinder. One option is directly on the burner we can heat water or we can heat milk. Another option can be with the help of LPG we can operate an engine. Yes, it is a fuel, it is hydrocarbon. With the help of that one we can operate engine. With the help of engine we can operate generator. We can obtain electricity. With the help of that electricity again we can heat water or milk. But this process will be inefficient. If LPG is directly being utilized for the purpose of heating of water and milk, that is more efficient because heat is being utilized for the purpose of heating only. If the whole process of engine, if you are using converting that heat into work and then we are utilizing, it is inefficient. So foremost challenge in the internal combustion engines are, they are very less efficient because heat will have to convert into work. The most efficient engines which we are getting these days, those are very large two-stroke engines, very large two-stroke diesel engines, which we are using for the purpose of marine applications. Very large two-stroke engines, where air-fuel ratio is very lean, and in that case, thermal efficiency of that two-stroke engine, it may reach around 50%. Maximum efficiency which we are achieving on this globe, that is through two-stroke diesel engines, and maximum efficiency I am saying it may be 50%. Normally the engines which we are using, say two-stroke petrol engine we are using, you will surprised to know the efficiency of these two-stroke engines are around 11-12%. Meaning of 11-12% thermal efficiency is, suppose 100 kilojoule heat we have given with the help of petrol to piston. Out of that one, only 12 kilojoule output we are getting on the crankshaft. 12% efficiency means output divided by input. Output high grade energy, input low grade energy. Low grade energy we have given 100 kilojoule heat to piston for the purpose of movement of the piston. But on the crankshaft, the work output which you are getting, that is high grade energy. If it is 12 kilojoule, so 12 kilojoule divided by input which you are given, that is 100 kilojoule. And we are saying thermal energy means thermal input which we have given, that is being compared with high grade output. So efficiency is 12%. So efficiency of two-stroke engines, petrol engines are very poor, very, very poor. When you are coming to four-stroke engines, in diesel engine, if I am saying normally for four-stroke engines, it is 25-26%, say 27% even. In some good engines, in direct injection engines, it may reach up to 28-29 like that one. Same is the situation of petrol engines also. Four-stroke petrol engines, again thermal efficiency is in the same range. Even if you are getting 28% efficiency, your losses are 100 minus 28, 72%. losses are there. So at this particular juncture, any researcher, if he is saying that I am able to improve the efficiency of these 4-stroke engines by 1%, 1% भी अगर कोई इस efficiency को improve कर देता है, 28 से 29 भी कर देता है, 29 से 30 कर देता है, probably he'll be the richest person of the world. जो efficiency को बढ़ा दे, इतने vehicles हैं अपने, इतने vehicles हैं, अगर इसकी efficiency को कोई बढ़ा सकता है, so certainly he'll be the richest person of the world. So the biggest challenge which we people are having, it is the thermal efficiency. It is efficiency of the engines. 15% of the total population are having vehicles. World is having population around 7 billion. 700 करोड़ population है पूरे विश्व की. उसमें से करीब 15% लोगों के पास vehicles हैं. They are owner of that one. So number of vehicles which we are having, it is slightly less than 1 billion, and in time to come it is being said up to 2022 it will be more than that one. 110 करोड़ के आसपास vehicles अपने पास हो जाएंगे, and if some circle is devised around the earth, some 125 circles will be there around the earth. These many vehicles are available on the earth. When auto and diesel somewhere in 1890, when they planned these cycles, that time they never thought of कि इस तरह के इतने इंजन आ जाएंगे, और इंजन आने से इंसान को फायदा भी होगा और इंसान को नुकसान भी होगा. कितना बड़ा नुकसान हो सकता है कभी भी, they are never thought of. Even those areas I will be covering कि कितना नुकसान हो रहा है इन इंजन से, particularly if you are discussing the sustainable development. एक अच्छी सी हवा में सांस लेने की बात हो, उस हवा को किस तरह से इस इंजन की वजह से डिटोरिएट हुआ है, स्पॉइल हुआ है, those issues also will be discussing. So first of all, when we are saying heat engines, it is converting heat into work. These engines are of two types. One is internal combustion engines, another one is external combustion engines. In internal combustion engine, the conversion of heat into work, and basically combustion of fuel is inside the cylinder, and then that heat is being utilized for the purpose of converting that heat into work, but combustion is taking place inside the cylinder. Another type of engines, heat engines, are external combustion engines, where the heat is being used at a different place and work output we are getting at a different place. Just like I have given the example of thermal power plants, steam engines, you are here, even steam power plants which we are saying, electrical power plants, those are in the category of external combustion engine. Even nuclear power plants. In the case of nuclear power plants, again, nuclear energy is being utilized for the purpose of heating the water. The water is getting converted into steam. Again, that steam is passing over the turbine blades, and finally, those water contents are getting entered into the boiler. So, heating is at another place, output we are taking at another place. And same is a gas engine, and these gas turbines where we are saying, where gas is the fuel, the gas is heating the water, and same cycle is of external combustion engines. So when combustion is taking place outside the cylinder, it is external combustion engine. When it is inside the cylinder, it is internal combustion engine. Always internal combustion engines are more efficient as compared to external combustion engines. And when I am saying efficient, when efficient word I am using, it is thermal efficiency. The term regularly we are using in the case of engines, when just efficiency we are saying, it means thermal efficiency, जिसके बेसिस पे इंजन्स को कंपेयर किया जाता है. सो पर्पज ऑफ दिस इंजन्स आर, आई एम सेइंग, इट इज कन्वर्टिंग हीट इनटू वर्क. ये मेनली जो है आपके पार्ट्स होते हैं इंजन के अंदर. इंजन के अंदर अगर देखें, तीन हिस्से हैं मेन इसके. तीन हिस्से हैं. एक सबसे नीचे वाला पार्ट, इट इज क्रैंककेस. बीच का पार्ट सिलेंडर ब्लॉक. टॉप का पार्ट, जस्ट लाइक ह्यूमन बीइंग, एट टॉप वी आर हैविंग हेड. In the same fashion, cylinder is having head. So cylinder head, block, and crankcase. These are three main parts. In between cylinder head and cylinder block, we are having gaskets, जिससे लीकेज आपका कहीं पे नहीं हो, न पानी का लीकेज हो न गैसेज का. पानी अपन सप्लाई करते हैं फॉर द पर्पज ऑफ कूलिंग. The gases which are there, it is due to combustion. The high pressure gases, it should not leak into the surrounding. So उस लीकेज को रोकने के लिए सिलेंडर हेड और ब्लॉक के बीच में अपन गैसकेट प्रोवाइड करते हैं. इसी तरह से गैसकेट अपन प्रोवाइड करते हैं नीचे क्रैंक केस और ब्लॉक को जोड़ने के लिए, वहां पे भी आपकी जो है गैसकेट्स हैं. एंड पर्पज ऑफ दोज गैसकेट्स आर टू अवॉइड द लीकेज ऑफ ऑयल. क्रैंक केस में आपका ऑयल होता है इफ इट इज 4 स्ट्रोक इंजन. इन 2 स्ट्रोक इंजन इट इज एम्प्टी. द पर्पज ऑफ द क्रैंक केस इज to supply air and fuel mixture. In the case of two-stroke engine, I am saying the purpose of the crankcase is to supply air fuel mixture, compressed air fuel mixture into the combustion chamber. That's the purpose of crankcase in the case of two-stroke engine. Whereas in the case of four-stroke engine, crankcase is having lubricating oil. Inside that one, we are having crankshaft. That crankshaft is connected to piston with the help of a connecting rod. The piston is moving, it is reciprocating movement, and reciprocating movement is getting converted into rotary movement, that is of the crankshaft. If it is a four-stroke engine, when all four strokes are completed, चारों एक्टिविटी जब पूरी होती है, चार एक्टिविटीज अपन कहते हैं. पहली एक्टिविटी जिसमें फ्रेश चार्ज को अंदर लेते हैं. इफ इट इज डीजल इंजन, फ्रेश चार्ज इज एयर. इफ इट इज पेट्रोल इंजन, फ्रेश चार्ज इज एयर प्लस फ्यूल वेपर्स. यस, पेट्रोल और एयर की मिक्सचर जो है, it is coming inside the cylinder. So that is first event, that is suction stroke. When it has been entered into the cylinder, more or less its pressure inside the cylinder is atmospheric. जैसे ही पिस्टन टीडीसी से बीडीसी पे आता है फ्रेश मिक्सचर को अंदर लेते हुए, when it reaches to BDC, more or less pressure inside the cylinder is atmospheric. Slightly it is lower than atmospheric. Slightly it is lower than atmospheric. After that one, both valves we are closing and we are compressing that mixture. If it is diesel engine, only air we have taken, that air will be compressed. If it is petrol engine, air plus fuel mixture will be compressed. Compression के बाद जो pressure temperature अपने को मिलता है, in the case of diesel engine, it is quite high. Just after compression, I am not saying after combustion, just after compression, the pressure temperature which you are getting, in the case of diesel engine, it is quite high. It may be around 31, 32, 35, even up to 40 bar. If compression ratio is 16, compression ratio is 16. After compression, the pressure which we are getting, it is around 38, 39 bar. Just अपन ने air अंदर लिया, दोनों वाल को बंद किया और compression stroke पूरा किया. That time if you are measuring the pressure inside the cylinder, when piston is near top dead center, if you are measuring the pressure of air, it is around 38, 39 bar. अगर ये पेट्रोल इंजन है जहाँ पे कंप्रेसर रेशियो नॉर्मली अपन 8, 9, 10 के आसपास रखते हैं, दैट टाइम प्रेशर इनसाइड द सिलेंडर विल बी 13, 14 बार. तो डीजल इंजन और पेट्रोल इंजन में फर्क ये हुआ कि डीजल इंजन सिर्फ एयर को ले रहा है, एयर को कंप्रेस कर रहा है, बट इट इज कंप्रेसिंग एट ए हायर प्रेशर, अप टू हायर प्रेशर इट इज कंप्रेसिंग. बट इन द केस ऑफ पेट्रोल इंजन, the pressure which you are getting after compression, that is bit lower pressure we are getting. So two events have been completed. First, fresh mixture we have taken in both the cases, in diesel and petrol, and in both the cases we have compressed. Compression के बाद petrol में we are having one intense source of energy, that is in the form of a spark plug. The energy which we are supplying through spark plug, it may range from 1 to 3 millijoules. The intense energy of source which we are having spark plug, it is giving intense energy for the purpose of initiation of combustion, because in that case already air plus fuel vapors are available and that spark plug is being used for the purpose of initiation of combustion inside the cylinder. आपके पास इतनी एनर्जी होनी चाहिए जो पेट्रोल की वेपर को एयर के साथ जला सके. The ignition temperature of petrol is quite high as compared to diesel. इसको कहते हैं SIT, सेल्फ इग्निशन टेम्परेचर. तो सेल्फ इग्निशन टेम्परेचर जो पेट्रोल का है, इट इज अराउंड 450 डिग्री सेल्सियस, करीब 450 डिग्री सेल्सियस इसका इग्निशन टेम्परेचर होता है. इतनी एनर्जी अपने पास होनी चाहिए विच कैन इनिशिएट द कंबशन इनटू द सिलेंडर. Whereas in the case of diesel engine, after compression of air inside the cylinder, we are injecting the diesel, and I said at the end of compression in the case of diesel engine, pressure is around 37, 38 bar. When it is 37, 38 bar, temperature inside the cylinder may become somewhere 350 डिग्री सेल्सियस, करीब 350 डिग्री सेल्सियस just compression से temperature हो जाता है. And in that atmosphere, if you are injecting the diesel का self ignition temperature, it is around 180 डिग्री सेल्सियस. डीजल करीब 180 डिग्री सेल्सियस पे बर्न हो सकता है, और मैं कह रहा हूं कंप्रेशन के बाद जो टेम्परेचर अपने क्रिएट कर दिया है, इट इज अराउंड 350 डिग्री सेल्सियस. सो इनसाइड द सिलेंडर टेम्परेचर ऑफ एयर इज 350 डिग्री सेल्सियस. इन दैट एटमॉस्फेयर वी आर इंजेक्टिंग द डीजल, इट सेल्फ इग्निशन टेम्परेचर इज अराउंड 180 डिग्री सेल्सियस. तो एयर का टेम्परेचर ज्यादा हो गया, डीजल का इग्निशन टेम्परेचर कम है, सो कंबशन ऑफ डीजल कैन बी इनिशिएटेड. बट इन दैट एनवायरमेंट, इफ वी आर इंजेक्टिंग द पेट्रोल, सपोज जिसका इग्निशन टेम्परेचर 450 के आसपास है, तो आपकी बर्निंग नहीं होगी पेट्रोल की। डीजल इंजन के कंप्रेशन के बाद, डीजल इंजन के अंदर एयर कंप्रेस करने के बाद अगर पेट्रोल इंजेक्ट करें वहां पे, कंबशन वोंट बी इनिशिएटेड बिकॉज ignition temperature of self ignition temperature of petrol is higher as compared to diesel. Yes. लेकिन आप देखना, कभी भी देखते हैं अपन इन ओपन, इफ डीजल एंड पेट्रोल आर लाइंग, कुछ बर्तनों में अगर पेट्रोल और डीजल पड़ा हुआ है, and if you bring a source of ignition, say matchbox we are having and matchstick if you are bringing near to petrol, चाहे उसका ignition temperature ज्यादा है लेकिन पेट्रोल जलना शुरू हो जाता है, डीजल वॉन्ट। आप देखना खुला अगर पेट्रोल डीजल पड़ा हुआ है, डीजल द पेट्रोल सीम्स मोर inflammable as compared to diesel. Reason for that one is the vaporization temperature of petrol is lower. At low temperature it can vaporize. So पेट्रोल की सरफेस पे पेट्रोल की वेपर्स अवेलेबल होती है, बट इन द केस ऑफ डीजल द वेपर्स आर नॉट अवेलेबल एट एटमॉस्फेरिक कंडीशंस। सो एयर फ्यूल मिक्सचर जो पेट्रोल की सरफेस पे बना हुआ होता है, मोर और लेस इट इज विद इन द कंबस्टिबल रेंज, एयर फ्यूल रेशियो जो है। तो जैसे ही आप जो है कोई सोर्स इग्निशन का लेके जाते हैं, पेट्रोल की वेपर्स आपको जलती हुई दिखती है, क्योंकि वो एयर फ्यूल मिक्सचर जो है ऐसा बन गया उसकी सरफेस के ऊपर, विच इज विद इन द कंबस्टिबल रेंज। बट इन द केस ऑफ डीजल आई एम सेइंग वेपराइजेशन ऑफ डीजल इज डिफिकल्ट, उसकी वेपर्स वहां पे होंगी नहीं एयर के साथ, सो नो बर्निंग विल बी देयर। नॉर्मली वन वर्ड वी आर यूजिंग, इट इज टर्म्ड एज फर्स्ट एयर फ्यूल रेशियो। मीनिंग ऑफ एयर फ्यूल रेशियो इज mass of air divided by mass of fuel which is required for the purpose of combustion. In the case of petrol engine, optimum air fuel ratio or chemically correct air fuel mixture which we are using, it is around 15 का मतलब ये है कि 15 किलो अगर हवा हो और 1 किलो पेट्रोल हो, the mixture is optimum for burning. It is optimum for burning. It is sometimes it is termed as stoichiometric air fuel ratio also, sometimes it is chemically correct air fuel ratio also. So vapor of petrol will be available over the surface, air will be available, and that air fuel ratio is responsible for starting the combustion. In the case of diesel engine, again these are the hydrocarbons, paraffins mainly, paraffins are dominating into this one. Petrol normally we can say some C8, H18, diesel we can say C12, some H28 like that one. So it is a mixture of hydrocarbons, but for the purpose of combustion, the mixture of air and fuel vapor should be available, then only combustion can be initiated. So diesel and petrol, if I am comparing, after compression, in the case of diesel engine pressure is higher, petrol engine is lower. In the case of diesel engine we are injecting the fuel in the form of diesel. In the case of petrol engine we are initiating the spark, and finally our purpose is to push the piston from TDC to BDC, नीचे अपने को लेके आना है जो क्रैंकशाफ्ट को रोटेट कर सके। एंड फाइनली फोर्थ इवेंट इज टू एग्जॉस्ट दोज बर्न प्रोडक्ट्स फ्रॉम द सिलेंडर। हम हमेशा ये चाहते हैं कि आपकी ज्यादा से ज्यादा फ्रेश मिक्सर सिलेंडर में आए और कंबशन होने के बाद not a single particle of burnt product should be available inside the cylinder. Our target is during the suction stroke, maximum amount of air and fuel should be taken into the cylinder within combustible range, more or less chemically correct, I am saying 15. And when we are opening the exhaust valve, when we are making those burnt products to go out, our target is that everything which has taken part into the combustion, the air, the CO2, O2, hydrocarbons, oxides, everything which is available, they should go out from the cylinder into the atmosphere. So optimum engine operation is maximum amount of air should be taken into the cylinder, and up to the possible extent the burnt product should go out. So 4 events are there, I am saying. One is suction, another one is compression, third one is expansion when power we are getting, and finally exhaust. During all these 4 strokes, speed of piston is different. Piston is moving at a different speed. Suppose suction is there, piston is going in downward direction. The crankshaft is making this piston to go down, and inlet valve is in open position. Suction, atmosphere, from atmosphere it is taking the fresh mixture into the cylinder. The piston is moving slowly towards the downward direction. When it will be moving up in compression stroke, both the valves are in closed position and piston has to compress the mixture. अब जब कंप्रेस करेगा तो इसका मतलब नेगेटिव फोर्स भी उसके अगेंस्ट में लग रहा है. इट मींस दैट टाइम speed of the piston will be slowest, lowest speed will be getting. One is suction stroke, reasonably higher speed. When it will be compressing, its speed will be minimum. And in third stroke, when power is being generated, when pressure inside the cylinder is significantly higher, that time piston is being pushed in downward direction, that time it will be having maximum speed. तब आपके piston की speed सबसे ज्यादा है. And finally, when we are exhausting the burnt products, again piston is moving in upward direction, but size of exhaust valve is very small, very small. So when it is exhausting the burnt product, the rate at which it is moving in upward direction, at the same rate burnt products are not going out from the cylinder. तो प्रेशर सिलेंडर के अंदर होता है, इट इज स्लाइटली हायर देन एटमॉस्फेरिक प्रेशर. जब आपका एग्जॉस्ट स्ट्रोक चल रहा होता है, जिस रेट से वो बर्न प्रोडक्ट्स को बाहर निकालने की कोशिश करता है, एट द सेम रेट्स बर्न प्रोडक्ट्स आर नॉट गोइंग आउट. सो प्रेशर इनसाइड द सिलेंडर विल बी हायर देन एटमॉस्फेरिक. तो उस टाइम भी स्पीड पिस्टन की कम रहती है. तो देखो आप चारों जो स्ट्रोक हो रहे हैं, उन चारों स्ट्रोक में पिस्टन की स्पीड डिफरेंट है. इट इज डिफरेंट. इवन एक स्ट्रोक में भी जो स्पीड अपने को मिलती है, एक स्ट्रोक में स्पीड मिलती है, दैट ऑल्सो इज डिफरेंट. सपोज जिस पॉइंट पे कंबशन स्टार्ट हुआ, where pressure is more than 40 bar, 45, even in the case of diesel engine, peak pressure after combustion may reach 80 bar. जब 80 bar pressure होता है, that time maximum forces are coming on the piston, that time speed will be very high. As expansion stroke is going on, pressure is getting reduced, speed of the piston is going down. So एक stroke में भी आपकी piston की speed different होती है. And when 4 strokes are completed, it is termed as one cycle has been completed. One cycle means 4 events have been completed, but in a cycle the speed of piston is different. Yes, and when one cycle is completed, your crankshaft will be rotating by 2 revolutions. If it is 4-stroke engine, if it is 2-stroke engine, the rotation of crankshaft, that is in 2-stroke. In 2-stroke, crankshaft will be rotating by 1 revolution. आपका 4 स्ट्रोक कंप्लीट होते ही क्रैंकशाफ्ट के 2 रिलेशंस हो जाते हैं, यानी 720 डिग्री ये रोटेट हो जाती है. होटेस्ट स्पोर्ट इन इंजन इज योर एग्जॉस्ट वाल्व. एग्जॉस्ट वाल्व इज द होटेस्ट स्पोर्ट. एंड अगर आपको पता करना हो सिलेंडर हेड खोल के, पर्टिकुलरली इन पेट्रोल इंजन, कि इसमें से एग्जॉस्ट वाल्व कौन सा है और इनलेट वाल्व कौन सा है, दोनों को पता करना हो, अपनी सिलेंडर हेड खोल लिया, जस्ट यू वांट टू फाइंड आउट दैट विच वन इज एग्जॉस्ट वाल्व, विच वन इज इनलेट वाल्व. In petrol engine, size of exhaust valve is smaller as compared to inlet valve. आपका इनलेट वाल्व का साइज बड़ा होता है पेट्रोल इंजन में, एग्जॉस्ट वाल्व का साइज छोटा होता है. बट इन द केस ऑफ डीजल इंजन, बोथ द साइजेस आर सेम. इनलेट वाल्व साइज एंड एग्जॉस्ट वाल्व साइज आर सेम. आई एम सेइंग एग्जॉस्ट वाल्व इज द होटेस्ट स्पोर्ट इन इंजन, and in petrol engine we don't want that any hot spot should be available inside the cylinder. Even if some hot spot is there, its size should be very small. Otherwise, it will be resulting into pre-ignition. It will be resulting into detonation. It is resulting into knocking of the engine. Knocking means ये unburnt mixture को ये exhaust valve ही जलाने लग जाता है. Not only spark plug, this exhaust valve is becoming source of ignition, and even near exhaust valve combustion can be started. और अगर ये combustion यहाँ पे start कर देता है, rate of pressure rise inside the cylinder may become quite high, and that is termed as knocking. So petrol engine में हमारे efforts रहते हैं कि कोई भी गर्म sport नहीं हो. Even if it is there, it should be smallest. So आपका जो mass है, even exhaust valve का जो mass है, जो heat capacity उसकी है, that should be minimum. Heat storage capacity should be minimum. पेट्रोल इंजन को हमेशा अपन चाहते हैं एटमॉस्फेरिक कंडीशन के आसपास ही ऑपरेट हो हमेशा. इवन जो मिक्सर जा रहा है, एयर फ्यूल मिक्सर, इट शुड बी वेरी नियर टू एटमॉस्फेरिक कंडीशन. अंदर इनसाइड द सिलेंडर वॉल्स एवरीवेयर वी वांट अराउंड एटमॉस्फेरिक टेम्परेचर शुड बी देयर, सो दैट नो हॉट स्पॉट शुड बी एंड कंबशन शुड बी नॉर्मल. ये आपका just I was telling your conversion of heat into work. E in, it is heat of the fuel, maybe petrol, maybe diesel, and finally E out is your useful output, your work output, your high grade energy output, and efficiency, which I am saying the ratio of E out divided by E in is around 25% in the case of 4-stroke engine, and it depends upon load also. It depends upon load also. It is not 25%, is not fixed. एक लोड की बात करें अपन, अगर इंजन की 5 किलोवाट आउटपुट है, सपोज डीजल इंजन है, अगर 5 किलोवाट आउटपुट है, इफ यू आर टेकिंग 5 किलोवाट फ्रॉम दिस वन, इट इज 100% लोडेड. At when diesel engines loading is 100%, its efficiency is also more or less 24-25%. But if loading is 50% only, आपका 5 किलोवाट की बजाय 2.5 किलोवाट ही लोड अपन ने ले रखा है, efficiency won't be 25, it may be some 13-14%. तो जैसे जैसे लोड बढ़ता है आपका, आपकी एफिशिएंसी जो है बढ़ती जाती है. In the case of engine where we are getting the maximum efficiency, again I am saying, when I am saying efficiency, it is thermal efficiency. The load at which maximum efficiency we are getting, it is termed as rated power. किसी भी इंजन की rated power का मतलब ये है कि वहां पे वो maximum thermal efficiency अपने को दे रहा है, जो मैं 25, 26, 27% की बात कर रहा हूं. So always we want that engine should work fully loaded. When it is fully loaded, more or less efficiency is at its peak. पार्ट लोडेड होगा तो कम होगा. लोडिंग की बात मैं जैसे कहूं, आपने कभी शादियों में देखा होगा, शादियों में डीजल इंजन होता है, उससे जनरेटर चल रहा होता है, उस जनरेटर से कुछ लाइटें जलाते हैं, बाजे और जो चलते हैं उसमें लाइटें जलाते हैं. मान लो इंजन का आउटपुट मैक्सिमम 5 किलोवाट हो सकता है और लाइटें जो उससे जुड़ी हुई हो अगर वो 1.5 किलोवाट की हो, तो लोड ऑन द इंजन विल बी 1.5 किलोवाट डिवाइडेड बाय मैक्सिमम 5 किलोवाट. सो लोडिंग आपकी करीब 30% लोडिंग है उस पे. जब 30% लोडिंग होगी आपकी, सो एफिशिएंसी ऑफ इंजन विल बी क्वाइट लो. बट अगर 5 किलोवाट का इंजन और 5 किलोवाट की लाइटें आपने उसमें लगा रखी है, then loading is 100% and that time maximum efficiency we can obtain. So target always is to operate these engines at its maximum capacity, maximum load पे अपन इसको ऑपरेट करें. करीब करीब अगर डिस्ट्रीब्यूशन देखें, अपन डिस्ट्रीब्यूशन देखें, आपको हीट से वर्क आउटपुट जब ले रहे हैं, कुछ आपका फ्रिक्शन में चला जाता है, कुछ एग्जॉस्ट के साथ, जो एग्जॉस्ट गैसेज भी जा रही हैं, they are going at a higher temperature than atmospheric. When we are taking fresh mixture into the cylinder, its temperature is atmospheric. But when burnt products are going out in the exhaust stroke into the atmosphere, their temperatures are higher than atmospheric. इसका मतलब उनके साथ कुछ एनर्जी है, और वो एनर्जी कौन सी है? जो पेट्रोल के कंबशन से या डीजल के कंबशन से एनर्जी मिली है, that has been added into that exhaust. So some energy is going through the exhaust, some energy is being lost in operating some of the mechanical components, just like your camshaft, your valves, your pumps, everything is getting operated with the help of that one. That energy is going into that one, and then we'll have to cool the engine. We'll have to cool the engine so that inside the cylinder temperature may somewhere around atmospheric temperature. वोल का टेम्परेचर है, it should be somewhere around atmospheric temperature. अगर बहुत ज्यादा वोल्स का टेम्परेचर होगा, अंदर सिलेंडर के अंदर वोल्स का टेम्परेचर ज्यादा होगा, बिकॉज मेटेलिक वोल्स आर देयर, देयर एक्सपांशन विल बी एट हाई टेम्परेचर, देयर एक्सपांशन विल बी, piston is also metallic, its expansion will be, if temperature is higher, then movement of the piston inside the cylinder will become difficult, because expansion की वजह से आपका diameter कम हो जाएगा and piston will be expanding, the diameter of piston will increase, so movement will become difficult. And always we want that inside the cylinder, on the cylinder walls, there should be layer of lubricating oil. Lubricating oil हो जो पिस्टन और सिलेंडर के बीच में फ्रिक्शन कम करे. If temperature inside the cylinder will be higher, lubricating oil won't stay on the cylinder walls. वो अगर उसकी विस्कोसिटी मेंटेन नहीं रहेगी, so it won't stay over the cylinder walls, it will be going into the crankcase. So it should be, temperature should be inside the cylinder, should be atmospheric, then only lubricating oil can stay over the cylinder walls. So for maintaining that atmospheric temperature inside the cylinder, continuously we'll have to cool the walls with the help of air or with the help of water or with the help of some coolants which we are using these days. कुछ हरे रंग का कूलेंट आपको दिखता है इंजन में, है ना, हरे रंग का दिखता है, इट इज ग्लिसरीन. जो हरा हरा कूलेंट अपने को दिखता है, बेसिकली फॉर कूलिंग द इंजन, द कूलिंग अरेंजमेंट विच वी आर हैविंग, it is glycerin, and normally the mixture is 50% water, 50% glycerin. And green color which is there, it is intensely we are adding dye, we are adding color, we are adding. वो कलर जो है ओरिजिनल कलर नहीं, इंटेंसली वी आर एडिंग. और उसका रीजन ये है कि सपोज व्हीकल वी हैव पार्क्ड समवेयर एंड फ्रॉम द रेडिएटर इफ सम लीकेज इज देयर, दैट ग्रीन fluid will be on the ground. So if leakage is there, driver immediately can recognize that some liquid is leaking. So the color which we are mixing intensely so that if leakage is there, that leakage can be traced with the help of that one. Yes, we are mixing glycerin into water. Reason for that one is, when we are mixing glycerin into water, the boiling temperature of water increases. If around 50% glycerin we are having in water, boiling temperature of water may be around 150 degrees Celsius. At normal atmospheric conditions, water boils at 100 degrees Celsius. But if you are mixing glycerin into this one, as percentage of glycerin is increasing while temperature increases. So 50% glycerin if you are having, temperature, boiling temperature become 150 degrees Celsius, and freezing temperature goes down. Freezing temperature may become some minus 30 degrees Celsius if 50% glycerin we are having. Suppose car we are using in Chandigarh in one case, another case we are using same car at Ladakh where temperatures are very low, particularly winter temperature may become some minus 15 degrees Celsius. If normal water we are using for the purpose of cooling at minus 15 degrees Celsius, it will become ice. If it will become ice, then no circulation, and if ice it is becoming, its volume increases, आपकी जो ट्यूब्स हैं कूलिंग के लिए, जो रेडिएटर की ट्यूब्स वगैरह है वो सारी ट्यूब्स फट जाएंगी. So for that purpose we are adding glycerin so that even at minus 15 degrees Celsius, minus 20 degrees Celsius, it will remain in liquid form. So आजकल जो कूलेंट काम में आ रहे हैं और इनका लॉसेस भी नहीं होता, बहुत टाइम बाद में अपने को कुछ एडिशनल डालना पड़ता है. The whole system is a closed system. Even vaporization at normal condition, vaporization of that one is not taking place. So no loss of coolant is there. But in earlier models of cars, if you see, कुछ ही दूर चलने के बाद 50 किलोमीटर चलने के बाद ड्राइवर यूज टू फाइंड आउट some डाबा, फ्रॉम देयर ही यूज टू टेक वाटर, ही वाज पुटिंग वाटर इनटू रेडिएटर एंड काफी गर्म सा अपने को वेपर आते हुए दिखते थे. नाउ दैट प्रॉब्लम हैज out and it has been resolved certainly, and the coolants which we are using, they are having higher boiling temperature and lower freezing temperature. लेकिन वो कूलेंट कुछ हीट लेके जाता है फ्रॉम इंजन, इट इज टेकिंग, it is rejecting into the radiator is taking air from atmosphere, it is passing over the radiator tubes and that heat is rejected into the atmosphere. तो अपन ने जो हीट दी उसका कुछ हिस्सा आपका बर्न प्रोडक्ट्स के रूप में चला गया एग्जॉस्ट गैसेस के साथ में, कुछ आपका वाटर के साथ में चला गया, कुछ एसेसरीज जिनको ऑपरेट कर रहे हैं इंजन के साथ में जो है, इवन योर इग्निशन सिस्टम, योर लुब्रिकेशन सिस्टम, योर फ्यूल सप्लाई सिस्टम, your crankshaft, your gears, many gears we are operating. So some of the energy is needed into that overcoming those resistances which are due to those accessories. So normally this is the distribution 30 30 30. Measure is 30 30 30. 30 thermal efficiency, that is output we are saying, it is thermal, the cooling losses, exhaust losses, and on the basis of this one we are preparing a sheet that is termed as heat balance sheet. Heat balance sheet एक इंजन की कि कितनी हीट अपन ने दी और वो हीट किस किस काम में आई, that balance if you are making, that is termed as heat balance sheet. कुछ टर्म्स अपन नॉर्मली काम में लेते हैं. One is bore, diameter of the cylinder, stroke, distance between TDC and BDC, then engine displacement between TDC and BDC. The diameter bore is say D, stroke is S or L. So between TDC and BDC, the volume which is available, it is termed as displacement, and above TDC and cylinder head, the volume which we are having, it is clearance volume. It is clearance volume. So सारे सिलेंडर का वॉल्यूम जो होता है वो डिस्प्लेसमेंट प्लस क्लियरेंस अगर जोड़ लें अपन, that becomes the total volume. Yes, total volume of the cylinder. So अपन बात करते हैं 800 सीसी की गाड़ी ये है या 100 सीसी का जो है इंजन है, सीसी is centimeter cube. cc is centimeter cube. So if 100 cc engine is, means between TDC and BDC, the volume which we are having, it is 100 centimeter cube. It is 100 centimeter cube. That displacement is there. If I add displacement and clearance volume, that becomes total volume. If that total volume is divided by clearance volume, it becomes, this term becomes compression ratio. If clearance volume and displacement volume I am adding and the same is being divided by clearance volume, the term become compression ratio. In the case of petrol engine, this compression ratio is around 8, 9. Earlier it was 6, 6.5, 7. Now efforts are being there to increase the compression ratio in petrol engine. जबकि डीजल इंजन में एफर्ट्स ये है कि कंप्रेशन रेशियो कम किया जाए. पेट्रोल इंजन में आज ट्रेंड ये है कि कंप्रेशन रेशियो बढ़ाएं अपन. इवन एट 10 व्हीकल्स आर बीइंग यूज्ड. आपके सीएनजी वगैरह जहां पे जिनका ऑक्टेन रेटिंग काफी ज्यादा है, कंप्रेशन रेशियो इवन 11.5 it is being used, but in the case of diesel engines, efforts are to reduce the compression ratio from 18 to 17.5, 17, 16. Even many of the Kirloskar engines which we are using, stationary engines, their compression ratio is 15. Lower the compression ratio of the diesel engine, starting becomes easier. इंजन को स्टार्ट करना अगर कंप्रेशन रेशियो कम है, starting is easier. Another one, the friction losses which we are having, it is lesser. Even leakage of the burnt products from the cylinder, it's lesser. Higher the compression ratio, higher the pressure inside the cylinder. If higher the pressure, the chances of leakage of burnt gases from the cylinder towards crankcase side, or from the valves it is become much more. So today's the trends are to reduce the compression ratio in the case of diesel engine and increase the compression ratio in petrol engine. In the case of petrol engine, we are increasing the compression ratio, means thermal efficiency is increasing. In the case of diesel engine, at 15 compression ratio, 16, 17, 18, more or less efficiency is constant. आपका lower compression ratio, if you are going up, we are reached to 15 compression ratio in diesel engine. After that, if you are increasing the compression ratio, the efficiency curve become flat. So effect of compression ratio above a certain limit, it is not significant. So that's why efforts are to reduce the compression ratio in the case of diesel engine. Another two more important terms we are using, and that is power and another one is torque. Suction stroke में अपना target है, if diesel engine to take air into the cylinder, if it is petrol engine to take air plus fuel mixture into the cylinder. During suction stroke, we want maximum amount of air or air fuel mixture should enter into the cylinder. एक स्ट्रोक में, एक सक्शन स्ट्रोक में जितना एयर फ्यूल मिक्सर अपन सिलेंडर के अंदर लेते हैं, फ्रेश विच वी आर टेकिंग, दैट इज टर्म्ड एज यूनिट एयर चार्ज. उसको अपन यूनिट एयर चार्ज कहते हैं. एक स्ट्रोक के अंदर, सक्शन स्ट्रोक के अंदर अमाउंट ऑफ फ्रेश मिक्सचर विच इज एंटरिंग इनटू द सिलेंडर, इट इज यूनिट एयर चार्ज. और यूनिट एयर चार्ज को हम हमेशा बढ़ाना चाहते हैं, ज्यादा से ज्यादा यूनिट एयर चार्ज हो. Torque depends upon, torque developed by the engine depends upon unit air charge. More the unit air charge, more the torque developed by the engine. And power depends upon how much air fuel mixture we are receiving into the cylinder per second or per minute. आपके यूनिट एयर चार्ज में टाइम नहीं है. यूनिट एयर चार्ज सिर्फ एक सक्शन स्ट्रोक का अपन कैलकुलेट करते हैं. That will decide the torque of the engine. But if per minute or per second amount of air which is entering, आपका सक्शन स्ट्रोक में एंटर होता है, फिर 3 स्ट्रोक में कोई फ्रेश मिक्सर एंटर नहीं होता, न कंप्रेशन में होता है, न एक्सपांशन में होता है, न एग्जॉस्ट में होता है. The mixture when it is entering into the cylinder, that time your inlet valve is in open position. It is termed as open cycle period. जब चारों स्ट्रोक को मिला देते हैं तो एक साइकिल बन जाती है. उस साइकिल में से सक्शन के टाइम when your inlet valve is in open position, that period is termed as open cycle period. After that, we are closing the inlet valve and we are compressing that one. No mixture is coming to the cylinder, no mixture is going out from the cylinder. That is termed as compression. The time of compression is in the category of closed cycle period. जब साइकिल आपका closed है, दोनों वाल्व आपके close है, no mass exchange is taking place with the surrounding. And in the suction stroke, mass is entering into the cylinder from atmosphere to cylinder. It is entering, and that entry we are assuming into the displacement volume, not on the clearance volume, not in the clearance volume. Clearance volume always is filled with burnt products, वो कभी बाहर नहीं जाते हैं. So the fresh mixture which is entering into the cylinder, that is only into the swept volume or displacement volume जिसको कह रहे हैं अपन. When piston is going downward in power stroke after initiating the spark, again there is no exchange of mass with the surrounding. कोई भी आपका मिक्सचर बाहर नहीं जा रहा है, कोई अंदर नहीं आ रहा है. Again it is in the category of closed cycle period. And finally your exhaust valve opens at the time of exhaust stroke and burnt products are going out. It is in the category of open cycle period. तो दो स्ट्रोक जो आपके हैं, सक्शन और एग्जॉस्ट, it is open cycle period. Compression and expansion is closed cycle period. Yes, where there is no mass exchange with the surrounding, from system to surrounding. If there is no mass exchange, it is closed cycle. तो क्रैंकशाफ्ट का जो 360 डिग्री मूवमेंट है ड्यूरिंग एक्सपांशन एंड कंप्रेशन, इट इज क्लोज साइकिल पीरियड. ड्यूरिंग सक्शन 180 डिग्री क्रैंकशाफ्ट रोटेशन, ड्यूरिंग एग्जॉस्ट 180 डिग्री क्रैंकशाफ्ट रोटेशन, it is in the category of open cycle period. Suppose one engine is running at the speed of 3000 rpm. rpm is revolution per minute. Suppose crankshaft is rotating by 3000 revolutions per minute. How many cycles will be there then? The crankshaft is rotating by 3000 revolutions per minute in 4 stroke. When 4 stroke is completed, one cycle is completed. If 4 stroke is completed, crankshaft is rotating by 2 revolutions. So when there is 3000 revolutions in a minute, how many cycles will be there? Half of that one. 4 स्ट्रोक में एक साइकिल होती है, और जब एक साइकिल होती है क्रैंकशाफ्ट के 2 रिवोल्यूशन हो जाते हैं. So if crankshaft is rotating by 3000 revolutions per minute, it means number of cycles which we are having, it is half of that one, 1500. And unit air charge, I am saying it is for one cycle. Amount of air which is entering into a cylinder in one cycle, एक suction stroke में. And per minute, if I'll be saying, per minute I'll be saying 1 unit air charge multiplied by number of cycles in a minute, that will be amount of air which has been entered into the cylinder per minute. So the power output of the engine depends upon how much fresh mixture has been entered into the cylinder per minute or per second, whereas torque depends upon amount of air fuel mixture enter into the cylinder in वन साइकिल, जिसको यूनिट एयर चार्ज कहते हैं. एक साइकिल को टॉर्क डिसाइड कर, एक साइकिल में जो मिक्सचर आ रहा है, फ्रेश मिक्सचर आ रहा है, इट विल डिसाइड द टॉर्क. बट पावर इज टाइम, पावर इज रिलेटेड विद टाइम. सो मिनट या सेकंड में जितना मिक्सचर सिलेंडर में एंटर हो रहा है, दैट विल डिसाइड द पावर. द फिजिकल मीनिंग ऑफ टॉर्क एंड पावर इज, सपोज आई एम हैविंग ए मोटरसाइकिल, suppose I am having a motorcycle and I'll have to overcome the loose sand. Some loose sand is there, some mud is there, I'll have to overcome that one. Torque will decide that if I'll be able to overcome that resistance or not. But power will decide how quickly I'll be able to overcome that one, because in that case time is coming into picture. I think it is clear the difference between torque and power. Torque will decide that we'll be able to overcome that resistance or not, and power will decide how fast, how quickly we'll be able to overcome that is, because time is coming to picture. So when we are deciding, when we are defining the volumetric efficiency, important part is volumetric efficiency. Volumetric efficiency decides the torque, and amount of volume of air entered into the cylinder per minute or per second, that will decide the power. वॉल्यूमेट्रिक एफिशिएंसी का मतलब ये है कि एक सिलेंडर का डिस्प्लेसमेंट वॉल्यूम 800 सीसी, जैसे मारुति कार है, अपने 3 सिलेंडर हैं, 800 सीसी 800 सेंटीमीटर क्यूब है, उस 800 सेंटीमीटर क्यूब के अंदर एयर को भर दें अपन एटमॉस्फेरिक कंडीशन के ऊपर, पूरा का पूरा 800 सीसी एटमॉस्फेरिक कंडीशन पे अगर भर जाता है, देन इट्स वॉल्यूमेट्रिक एफिशिएंसी इज 100%. बट व्हाट हैपेंस व्हेन पिस्टन इज गोइंग इन डाउनवर्ड डायरेक्शन, साइज ऑफ द वाल्व, इनलेट वाल्व इज वेरी स्मॉल, air which is coming from the atmosphere, it has to face many resistances in the path. First of all, there is air filter, वो रोकता है एयर को. जिस स्पीड से पिस्टन नीचे जा रहा है, the valve is in open position, the rate at which piston is moving in downward direction, at the same rate air is unable to follow the speed of the piston, because first air filter is obstructing the flow of air. Then there is intake manifold. In the intake manifold many bands are there, yes, and if it's petrol engine there is a carburetor also. If carburetor is there, there is throttle valve, there is venturi also. So through that one, when air is passing, lot of pressure drop is there. If pressure drop is there, so when it will be finally entering into the cylinder, its pressure will be lower than atmospheric. It won't be atmospheric pressure. So I am saying volumetric efficiency of the engine will be 100% if cylinder is filled at atmospheric condition. But because lot of obstructions are there, they are not permitting air to flow into the cylinder freely. So when finally air is available into the cylinder at the end of induction stroke, in inlet stroke, suction stroke, the air which will be available when piston will be at BDC at the end of suction stroke, the air which will be available in the cylinder, its pressure is lower than atmospheric. If its pressure is lower, then density is also lower. Density is P by RT. At atmospheric condition, P is atmospheric pressure, but density, when I am calculating the fresh mixture which is available inside the cylinder, its density will be lower than atmospheric, because pressure has gone down. Even if T is same, R is constant, if pressure is lower, density is lower. So mass of air which is inside the cylinder, it is volume of the cylinder multiplied by density. Volume I am saying 800 cc, but density has gone down. It means amount of air which we could trap into the cylinder, it is lesser as compared to when conditions would have been atmospheric. तो अगर वॉल्यूमेट्रिक एफिशिएंसी बढ़ानी है अपने को, अगर 100% लेके आना है, so effort should be whatever resistances are there in the flow of air, those resistances should be reduced, it should be removed. Advantage with diesel engine is, in the case of diesel engine, there is no carburetor, just freely air is entering into the cylinder. So normally the volumetric efficiency of diesel engines are higher as compared to petrol engine, because obstructions are not there. Yes, so these are the major terms which normally we are using. This is bore I am saying, the diameter I am showing of the cylinder, it is bore. Then I am showing piston, top of the piston. If it is a petrol engine, top of piston is flat. It's a flat. Yes. But if it is diesel engine piston, even by seeing you can recognize. In the case of diesel engine piston, there is a dip, there is a bowl. Yes. Top is not flat. Part of the top is in the form of a bowl, or more or less we can say clearance volume at the end of compression, the air which will be, it is more or less in the bowl. सारी की सारी एयर जो है कंप्रेशन के बाद उसके अंदर आ जाती है. There is a specific purpose for creating this bowl, having this bowl. In the case of diesel engines, it's very important because separately we are taking air, separately we are injecting the diesel. जैसे मैंने इनॉग्रेशन पे मैं बात कर रहा था, it is just like कोर्ट मैरिज, कोई तैयारी नहीं है. एक साइड से एयर ले ली अपन ने, we have compressed that air and in that atmosphere we are injecting the diesel. Our sole target is that diesel particulates should come in contact with air rapidly. When they'll be coming in contact with air, then proper air fuel mixing will be there. So for making that air fuel mixing proper, our target is that air should rotate rapidly. Air should rotate. If in rotating environment we are injecting the diesel, then chances of formation of air fuel mixture, proper air fuel mixture will be better. This rotation of air, which is very important in diesel, in petrol it is not important, because in petrol already we have mixed the air fuel into the carburetor and that mixture we are supplying into the cylinder. Even during suction stroke it will be mixing, then we are compressing. Still if it is mixing is not proper, during compression time it will be mixed and then we are initiating the spark. But in the case of diesel engine, separate processes are there, separate entry of air is there and separate diesel is there. So first of all, entry of air in the case of diesel engine, our efforts are it should be tangential entry. Air should enter tangentially. If tangential entry is there, it will be having two components of velocity when it is entering into the cylinder. One is horizontal, one is vertical. Vertical component will try to move the air in downward direction, but horizontal component will try to rotate the air into the cylinder. So always entry of air in the case of diesel engine is tangential, and this movement is known as swirl, SWIRL. Swirl is a guided movement of air, and in that atmosphere we would like to inject the diesel. Another one, I am saying there is a bowl in the piston. The bowl in the piston, and the injection which we are doing, that is towards the bowl. The injector is injecting more or less fuel inside the bowl. When piston is coming in compression stroke, all the air will enter into the bowl. When it will be entering into the bowl, and there we are injecting the fuel. But when piston starts to go down into the towards the bottom dead center, the air should go out. Air is go out. So one movement was like this one. In another direction, when it is coming out from the bowl at the time of expansion, the movement of air will be like this one. Another plane it is moving, that is termed as squeeze. One is swirl, that it is in this plane air is rotating. With the help of bowl, we are making air to rotate in this plane. So resultant velocity will be quite high. Swirl and squeeze resultant velocity which will be getting, in which we are injecting the diesel, that velocity will be quite high, and it is helping in mixing of air and diesel inside the cylinder. So पिस्टन जो डीजल इंजन के होंगे वो डिफरेंट तरह के होंगे, और वहां पे अपना पर्पज ये है कि जल्दी से जल्दी डीजल और आपकी एयर कांटेक्ट में आए, जबकि पेट्रोल इंजन में इस तरह के मूवमेंट की अपने को जरूरत नहीं होती. सो दैट्स व्हाई पिस्टन ऑफ द पेट्रोल इंजन आर फ्लैट. एक फायरिंग ऑर्डर भी काम में लेते हैं अपन. द फायरिंग विच वी आर डूइंग इन द सिलेंडर्स, it is important in multi-cylinder engines. These days, the number of cylinders which we are using, normally in cars there are 4 cylinders, in trucks it is 6 cylinder, even it is 8 cylinders also, in buses 6 cylinders, 8 cylinders. So number of cylinders are more. Your firing order is becoming very important. So 4 cylinder engine, the output which we are taking from the crankshaft, and the forces which are coming, that is also coming on the crankshaft. One option may be all the cylinders should fire at one particular time. Then the crankshaft will be getting the maximum force. That exactly we don't want. We want that in one cylinder, suppose it is going through power stroke, another cylinder should go through compression stroke, another stroke should go to exhaust stroke, another cylinder should go to suction stroke. Like that one we want. So say first cylinder, suppose it is going through the power stroke, another may be related near to that one, it may be going through exhaust stroke. First, in the case of petrol engine, any cylinder where combustion is going on, nearby cylinders, because it is inline cylinders are inline का मतलब सारे cylinder एक line में. Suppose cylinder number 3 is giving power where combustion is going on, it is hottest, this cylinder is hottest. Remaining cylinder, somewhere it is suction stroke in some cylinder exhaust is there, some cylinder compression is there. So suppose nearby cylinder is having compression stroke and this cylinder is going through power stroke, it is possible because your combustion in the cylinder is going on, nearby cylinder they are made with cast iron, they are made with aluminium, so lot of heat from the combustion cylinder may be transferred to the cylinder where compression is going on. तो उस कंप्रेशन जिसमें चल रहा है उसका भी टेम्परेचर ये बढ़ाने की कोशिश कर देता है, बढ़ा देता है. In we never want that heat exchange among the cylinders should be. If it is among the cylinders, particularly when power is going on, nearby cylinder is in compression stroke, ये heat इतनी इसके अंदर जनरेट कर सकता है, even chances of auto ignition will be in that cylinder. And knocking increases if continuous firing is there of cylinder number 3, then it is 4, then it is 2, like that. And we want to avoid this heat transfer. And second one, we want that power which is coming on the crankshaft, it should be continuous and it should be balanced. Suppose it is coming from cylinder number 1, then it should come from cylinder number 3. So this side of bearing should have effective load. Other side, when it is cylinder number 1, so that side bearing load was there. Now it is at third, bearing load is here. So balancing will be there. So balancing of the crankshaft of the forces and thermal reasons are that we don't want to transfer the heat from one cylinder to another cylinder. That's why the firing order which we are fixing, 1 is firing, then 3 is firing, then 4 is firing. Near to 3, 4 can fire because it is connected to atmosphere where lot of, even if some heating is there from 3 to 4, 4 is rejecting heat to the atmosphere, it may not be effective, and then after 4 it is 2. So this is firing order. This is very, very important in every cylinder. It is very, very important. And two major reasons for the firing order are told, that is, one is thermal reasons of heat exchange reasons, and another one the forces which are coming, that's the reason. This is normal pistons are like this one. In one there is power, जो मैंने ये पिंकिश जो दिख रहा है ये पावर हो रही है, यहाँ पे कंबशन हो रहा है, इसके अंदर साइड वाले के अंदर एग्जॉस्ट हो रहा है, एक के अंदर आपका सक्शन हो रहा है, एक के अंदर कंप्रेशन हो रहा है, लाइक दैट वन. दिस बैलेंसिंग इज देयर. दिस इज फायरिंग ऑर्डर. दिस इज फायरिंग ऑर्डर. आपका पेट्रोल इंजन के अंदर आई सेड वी आर हैविंग स्पार्क प्लग फॉर द पर्पस ऑफ इनिशिएशन ऑफ कंबशन. In the case of diesel engine, we are having injector which is injecting the fuel. The pressure of injection is very, very important in any diesel engine. Pressure in the cylinder after compression, I said it is around 40 bar. I said just air we have compressed, pressure is 40 bar into the cylinder, and now in that atmosphere we will have to inject the diesel. So certainly pressure of diesel should be higher than the pressure of air which is inside the cylinder. Normally the pressure which we are keeping for starting the injection, that is termed as injector needle lift pressure. That pressure is around 200 bars. जिस टाइम पे इंजेक्शन शुरू होता है आपका इंजेक्टर से, that pressure is around 200 bar. So inside the cylinder pressure is 40 bar, and the fuel pressure which is coming into the cylinder, it is around 200 bars. But that pressure doesn't remain constant. Your injection is not instantaneous, it is for some duration. जैसे इंजेक्शन शुरू हुआ और कहीं पे जाके कुछ टाइम बाद वो आपका क्लोज होगा. So starting point of injection and ending point of injection, it is some finite time we are having. So point at which your injection starts and point at which it closes, the pressure is not same. The rate at which the fuel pump is pushing the fuel towards the injector through the injector holes, through the injector nozzles, the nozzle hole size is very, very small, say around 0.2 mm size is there. Some nozzles are of single hole, their diameter is bit larger, but majority of the nozzles which we are using for the purpose of injection inside the cylinder, they are multi-hole. Sometimes it is 3 holes and sometimes it is 5 holes. In the case of trucks, buses, large engine, 5 hole nozzles are there. In smaller engine, 3 hole nozzles are there. So the rate at which the fuel pump is pushing the diesel towards the injector, at the same rate liquid is not getting injected into the cylinder because the size of those holes are very small, and liquid we can't compress. piston is the pump, fuel pump is trying to send that fuel into the cylinder, but at the same rate it is not getting injected, and I'm saying we can't compress the liquid. So piston is trying, the fuel pump is trying to compress the liquid, and it is not getting injected. It means rate of pressurize of the fuel in the pipeline, it becomes very high. Rate of pressurize becomes very high. और ज्यादातर पाइपलाइन आप लोगों ने देखा होगा, जो फ्यूल पंप और इंजेक्टर के बीच में पाइपलाइन होती है, इट इज स्टील थिक पाइपलाइन होती है, जिसके अंदर जो जो होल चलता है, इट इज वेरी स्मॉल, एंड fuel is getting transferred from pump to injector. So even in that pipeline, pressure may become around 1000 bar at the time of injection. Initially I am saying when your injector needle lifts, that time pressure is 200 bar, but injection is for some finite time. Continuously the fuel pump is forcing the diesel to go into the cylinder, but same rate it is not getting injected. It means in the pipeline the pressure increases rapidly, it is increases. So when we are ending the injection, even pressure may reach to 1000 bars. So these days efforts are to increase the injection pressure. इंजेक्शन प्रेशर बढ़ाएं, जिसे ड्रॉपलेट साइज जो डीजल जो इंजेक्ट हो रहा है, द साइज ऑफ द ड्रॉपलेट शुड बी स्मॉलर. इफ इट इज स्मॉलर, vaporization of those droplets inside the cylinder will be better in the air, and combustion of diesel will be better. When we are injecting the diesel into the cylinder, at the it not starts to burn. जैसे इंजेक्ट किया वो बर्न होना शुरू नहीं होगा. First of all it has to vaporize, first of all it has to atomize, then it has to vaporize. It is getting heat from the air, which is compressed air after the compression stroke. When it is taking heat from that, and then it is vaporizes. And not only vaporization, its mixing is important. Mixing with air is important. So first is atomization of that one, second one vaporization of that one, and third one mixing of that one. All these three processes which I am mentioning, it is physical delay. It is physical process. We have started to inject the diesel, but it has not started to burn because इसके physical processes कुछ जो है पूरे हो रहे हैं. When physical processes will be completed, then some chemical reaction starts to take place. That is chemical delay. तो combustion कब start होगा आपका? जब आपका physical delay पूरा हो जाएगा और जब आपकी chemical reactions which are required for the start of combustion will be completed. So starting point of injection and starting point of combustion is different. जिस पॉइंट पे आपका इंजेक्शन होना शुरू हुआ है सिलेंडर के अंदर और जिस पॉइंट पे कंबशन होना शुरू हुआ है, इट इज डिफरेंट, एंड द डिफरेंस इज ड्यू टू फिजिकल डिले एंड ड्यू टू केमिकल डिले. उस दौरान आपका फ्यूल अंदर इकट्ठा होता रहता है. डीजल इंजन के अंदर फिजिकल डिले और केमिकल डिले जब तक चलता रहता है, नया फ्यूल उसके अंदर आता रहता है. एज एंड व्हेन दिस फिजिकल एंड केमिकल डिले कंप्लीट्स, that particular point of time enough fuel is available inside the cylinder for the purpose of combustion. So immediately when combustion will start, that time lot of fuel and air available for the purpose of combustion, वो एकदम से combustion करता है, एकदम से जो है severe blast type होता है डीजल इंजन के अंदर, and that phenomena is knocking phenomena. डीजल इंजन के अंदर combustion जो start होता है वो आवाज करते हुए start होता है. It is creating lot of noise, क्योंकि काफी फ्यूल डिले पीरियड के टाइम जो है इकट्ठा हो गया है. Always efforts are that delay period should be minimum. Delay period should be minimum, so that when combustion starts, the amount of fuel which is available into the cylinder, that should be less. If lower the delay period, the amount of fuel which has entered during delay period, that will be lesser. So when combustion will start, ये आपका रेट ऑफ प्रेशराइज कम होगा. रेट ऑफ प्रेशराइज कम होगा तो नॉइज कम होगी. आज अगर अपने को गाड़ी खरीदनी हो, one option is I can purchase petrol car, another option is I can purchase diesel car. I am preferring petrol vehicle because noise of the engine is lesser as compared to diesel. In the case of diesel engine, reason is during delay period lot of fuel is being collected, and as and when combustion starts, it is creating lot of noise. Rate of pressurize काफी ज्यादा, वो प्रेशर वेव सिलेंडर वॉल्स पे जाके टकराती हैं और आवाज करती हैं. So in the case of diesel engine, one term we are defining, that is C10 number. एक C10 number term काम में लेते हैं. Higher the C10 number, lower the chemical delay. Lower the chemical delay means total delay reduces and knocking tendency जो है कम हो जाती है. रेट ऑफ प्रेशराइज कम हो जाता है, इग्निशन डिले के टाइम फ्यूल कम कलेक्ट होता है. Smaller the C10 number, smaller the C10 number, longer the chemical delay. अगर ज्यादा डिले लंबा हो गया तो फ्यूल ज्यादा कलेक्ट हो जाएगा, ज्यादा नॉइज करेगा. C10 number of petrol is very low, octane number is high, whereas C10 number of diesel is higher, octane number is lower. अगर आपने पेट्रोल डालना शुरू कर दिया डीजल इंजन के अंदर, अगर पेट्रोल सप्लाई कर दें where C10 number of petrol is very low, if that fuel will be supplying in diesel engine, it will be creating lot of noise, बहुत ज्यादा नॉइज होगी कि आपका कंबसन शुरू होने से पहले केमिकल डिले इतना लंबा होगा कि सारा का सारा फ्यूल जो उस साइकिल में जाना चाहिए था सारा फ्यूल उसमें इकट्ठा हो जाएगा, तब तक भी कंबसन शुरू नहीं होगा बिकॉज केमिकल डिले इज longer. As and when combustion will be initiated, there will be lot of noise into the cylinder, काफी ज्यादा नॉइज जो है होगी. तो कभी भी अपन डीजल इंजन के अंदर पेट्रोल काम में नहीं ले पाते ड्यू टू दिस कंबस्शन रीजन्स, ड्यू टू दिस कंबस्शन रीजन्स. यस, जबकि पेट्रोल इंजन के अंदर विल बी हैविंग स्पार्क प्लग and spark plug is initiating the spark, but till that time when we are initiating the spark, till that time all the physical processes, आपका ऑटोमाइजेशन मिक्सिंग वगैरह सब कंप्लीट हो चुका है, कार्बोरेटर में ही हो गया, सक्शन स्ट्रोक के टाइम हो गया, कंप्रेशन के हो गया. सो देयर इज नो फिजिकल डिले, नो फिजिकल डिले इन द केस ऑफ spark ignition engine. Only when we initiated the spark and actually flame starts to propagate, in between time which is being taken, that is in this chemical delay, chemical reactions. So in the case of diesel engine, the term which we are using, it is ignition lag. जो chemical reaction जब पूरी होती है उसको ignition lag कहते हैं अपन. In the case of diesel engine, there are two processes of that delay or lag. One is physical processes, another one is chemical processes. पेट्रोल इंजन के अंदर अपन केमिकल डिले बढ़ाना चाहते हैं हमेशा. हायर द ऑक्टेन नंबर मींस लॉन्गर द इग्निशन लैग, लॉन्गर द केमिकल रिएक्शन टाइम. इन द केस ऑफ डीजल इंजन, वी वांट टू रिड्यूस द केमिकल रिएक्शन टाइम, मींस हायर द C10 नंबर, लेसर द केमिकल इग्निशन डिले. अगर आपने पेट्रोल इंजन के अंदर डीजल डाल दिया, इन द केस ऑफ पेट्रोल इंजन वी नीड लॉन्गर केमिकल रिएक्शन टाइम, whereas C10 number, when I am saying significant C10 number around 45 which you are using in diesel fuel, here C10 number higher means chemical delay is lower. अगर आपने डीजल आपने पेट्रोल इंजन में डाला, अगेन चांसेस ऑफ सीवियर नॉकिंग विल बी देयर. जब आपका ऑक्टेन नंबर कम होता है तो केमिकल रिएक्शन का टाइम कम हो जाता है, और जैसे ही आपने स्पार्क किया हो सकता है सारा फ्यूल बर्न हो जाए. नो केमिकल रिएक्शंस विल बी एंड रैपिडली द फ्यूल विल बी बर्निंग. सो आपका कभी भी डीजल फ्यूल जो है पेट्रोल इंजन के काम का नहीं हो सकता, और पेट्रोल जो है डीजल इंजन के काम का नहीं हो सकता. दे आर जस्ट लाइक एनिमीज. इन फैक्ट द डीजल एंड पेट्रोल आर जस्ट लाइक एनिमीज. दे डोंट वांट टू सी ईच अदर. ऑल द कैरेक्टरिस्टिक्स ऑफ दीज फ्यूल्स आर डिफरेंट. वो किसी को एक दूसरे को देखना नहीं चाहते. आजकल जितने गैसेस फ्यूल्स काम में ले रहे हैं अपन, चाहे सीएनजी काम में ले रहे हैं, चाहे एलपीजी काम में ले रहे हैं, चाहे बायोगैस आपने काम में ले रहे हैं, all we are using in spark ignition mode, and reason for that one is their octane ratings are quite high. Octane rating of petrol which you are using, it is 90. If octane rating of LPG, if I am saying, it is around 100. Octane rating of CNG, if I am saying, it is more than 100, it is 120. So जितने gaseous fuels हैं उनको अपन spark ignition mode में ही यूज करना चाहते हैं, because they are not knock prone. उन गैसेस की वजह से नोकिंग आपकी काफी कम होती है. बट उन गैसेस को अगर इन डीजल इंजन में काम में लें, इन सम ड्यूअल फ्यूल वी आर यूजिंग, there the severe knocking with these gaseous fuels will be. So this is the difference between diesel and petrol engine. This is the difference, and major difference is their combustion characteristics. Their combustion characteristics are different. The calorific value, petrol diesel more or less comparable. Petrol engine it is higher, diesel slightly it is lower. Remaining properties are same. Heat contents I am saying same, but remaining properties, even viscosity, even self ignition temperature, even octane rating, if I am saying, even flash point, fire point, these characteristics are different of those of both these fuels. ये आपका कार्नोट साइकिल में दिखा रहा हूं. कार्नोट साइकिल का पर्पस भी हीट को वर्क में कन्वर्ट करना. हीट को वर्क में कन्वर्ट करता है कार्नोट साइकिल, and it is termed as most efficient cycle. Most efficient cycle. These are air standard cycles. In the case of Carnot cycle, working fluid is air. Air is working fluid. There is no combustion inside the cylinder. Carnot engine की जब बात करते हैं, कोई combustion उसमें नहीं हो रहा, कोई fuel supply नहीं हो रहा है. Just we are compressing the air. After compression with external source, we are adding the heat. Heat जो external source है, heat source से अपन air के अंदर heat add करते हैं. So इसमें पहली जो लाइन आ रही है आपकी हीट इन जो दिखा रखा है, it is piston is moving from TDC towards BDC, it is moving, and this red line which is being shown, it shows that temperature inside the cylinder is constant, कि टेम्परेचर सिलेंडर के अंदर कांस्टेंट है, सिलेंडर में एयर भरी हुई है जिसको अपन ने कंप्रेस कर रखा था, एंड टॉप ऑफ द सिलेंडर हेड इज ए गुड कंडक्टर, थ्रू दैट वन outside the cylinder head we are keeping one hot body, that hot body is supplying heat to air. When it is air is getting heat, piston starts to move in downward direction. When piston will be moving in downward direction, the air will be expanding. Due to that one, temperature of air should go down, but same time with external source we are adding the heat. तो पिस्टन के मूवमेंट की वजह से तो टेम्परेचर कम हो रहा है, बट एक्सटर्नल सोर्स इज एडिंग द हीट इनटू द एयर. सो दिस पिंक line which is being shown from top to middle of that one, it is heat addition at constant temperature. constant temperature क्यों रहा, constant temperature क्यों रहा, उधर से तो heat add कर रहे थे अपन, वो temperature बढ़ा रहा था, but same time piston was going down, it was expanding the air, it was resulting into decrease in temperature. so piston के movement से temperature decrease हो रहा है, heat addition के वजह से temperature increase हो रहा है, net effect is to keep the temperature constant. so heat addition अपने कार्नोट साइकिल में constant temperature पे. और उसके बाद जो आपको वायलेट लाइन दिख रही है, उस टाइम हीट सोर्स को अपन हटा लेते हैं, एयर है, गर्म हुई एयर है, हीट सोर्स को अपन ने हटा लिया, एंड रैपिडली पिस्टन वी आर मूविंग टुवर्ड्स द बॉटम डेड सेंटर, कि कोई हीट एक्सचेंज नहीं हो, इट इज रिवर्सिबल एडियाबैटिक, कि पिस्टन सिलेंडर के बीच में अपन ने अज्यूम किया देयर इज नो फ्रिक्शन, heat which you added at constant temperature, after that one remaining stock is being covered rapidly and without any friction between cylinder and piston, and कोई भी heat exchange नहीं हो रहा है आपका. if there is no exchange of heat, there is no heat generation due to friction, the process is termed as reversible adiabatic. so पूरा स्ट्रोक जो कंप्लीट हुआ है वो दो भागों में कंप्लीट हुआ है, अपने हीट ऐड की कांस्टेंट टेम्परेचर पे, और बाद में जो एक्सपांशन किया है रिमेनिंग पार्ट में, इट इज रिवर्सिबल एडियाबैटिक. कांस्टेंट टेम्परेचर पे हीट ऐड किया है, एंड हीट सोर्स का टेम्परेचर और एयर के टेम्परेचर में बहुत कम गैप था. अगर हीट सोर्स आपका बहुत ज्यादा टेम्परेचर पे हो एंड इनसाइड दिस सिलेंडर इफ टेम्परेचर ऑफ एयर इज लोअर, देयर इज लॉट ऑफ इरिवर्सिबिलिटी. हम चाहते हैं कि कार्नोट साइकिल में कोई इरिवर्सिबिलिटी, कोई लॉस नहीं हो. सो द टेम्परेचर ग्रेडियंट बिटवीन हीट सोर्स एंड एयर विच इज अवेलेबल इनसाइड द सिलेंडर, इट इज मिनिमम डिफरेंस, और एक्सपांशन भी आपका रिवर्सिबिलिटी, यहां तक कोई लॉस नहीं हुआ, कोई लॉस नहीं हुआ. इसका मतलब जितनी हीट अपने सप्लाई की सारी आपकी वर्क आउटपुट में कन्वर्ट होनी चाहिए. you should get this fundamental of this one, that whatever heat we are supplying, if there is no loss, everything should be converted into work, convert होनी चाहिए. लेकिन अपने क्या कह रहे थे कि कन्वर्ट होने के लिए साइकिल कंप्लीट होनी चाहिए, जहां से अपन शुरू हुआ था पिस्टन अपने को वापस वहीं पहुंचना है. we are reached to the BDC, two processes has been completed, one constant temperature heat addition and then expansion reversible adiabatic. अब अपने को क्या करना पड़ रहा है, वापस अगर पिस्टन को ऊपर लेके जाना है, पिस्टन ऊपर तभी जाएगा when temperature of air will be lesser, कि प्रेशर कम हो, then only piston can go up. bottom side of the piston will be having atmospheric pressure, inside the cylinder if pressure is lower than atmospheric, then piston can go up. वो lower तब हो सकता है जब जो एयर के पास हीट है उसको बाहर रिजेक्ट कर दें अपन, then only pressure inside the cylinder can come down, temperature can go down. तो ये जो फिर रेड लाइन दिख रही है हीट आउट वाली, ये अपने को हीट इंटेंसली आउट करनी पड़ रही है to make the piston to move in upward direction so that cycle should be completed. जैसे ही वो बीच में आ जाता है कहीं पे, हीट सोर्स जो हीट बाहर जा रही थी अपन इंसुलेट कर देते हैं उसको, एंड रिवर्सिबल एडियाबैटिक मूवमेंट ऑफ पिस्टन अप टू द पॉइंट फ्रॉम वेयर इट हैज बीन स्टार्टेड. तो कितने चार प्रोसेसेस हो गए आपके, चार प्रोसेसेस. हीट एडिशन वाज एट कांस्टेंट टेम्परेचर, देन रिवर्सिबल एडियाबैटिक एक्सपांशन, then heat rejection again at constant temperature. आपकी हीट बाहर जा रही है but piston is moving in upward direction, due to movement of piston in upward direction it is compressing the air, but same time it is rejecting the heat. तो heat rejection की वजह से टेम्परेचर कम हो रहा है, कंप्रेशन की वजह से बढ़ रहा है, again temperature will remain constant during heat output, and finally reversible adiabatic compression. तो इस साइकिल की एफिशिएंसी 100% क्यों नहीं हो सकती, इसमें कोई लॉस नहीं है, सिर्फ एक प्रोसेस जो हीट रिजेक्शन का अपन ने किया है, ये हीट रिजेक्शन होने की वजह से आपकी कार्नोट साइकिल की एफिशिएंसी कभी भी 100% नहीं हो सकती, बिकॉज द हीट विच यू आर गिवन एज एन इनपुट फ्रॉम द हीट सोर्स, part of that one we rejected into the atmosphere so that cycle can be completed. If you are making this cycle to be completed, some heat we have rejected into the atmosphere. Even the Carnot cycle, all the processes are reversible adiabatic process, but still its efficiency is not 100%. अब इसके अंदर दिक्कत ये आ रही थी कि चारों बार स्पीड अलग अलग, जब कांस्टेंट टेम्परेचर है तो हीट को आने के लिए जो टाइम लग रहा है उसके लिए पिस्टन को स्लोली मूव करना है ताकि टेम्परेचर कांस्टेंट रह सके। बट जब अपन चाहते हैं कोई हीट एक्सचेंज नहीं हो, रिवर्सिबल एडियाबैटिक, देन मूवमेंट ऑफ द पिस्टन शुड बी वेरी रैपिड। Then again constant temperature heat rejection, again piston should move slowly, and then finally reversible adiabatic compression, again piston has to move very rapidly. So in a cycle 4 times piston speed is changing, so practically we can't use this engine. So इसका जो इम्प्रूवमेंट किया था वो ऑटो ने किया था। इस साइकिल को जो इम्प्रूव किया 1890 में, इट हैज बीन इम्प्रूव्ड बाय ऑटो। एंड हीट एडिशन उसने क्या कहा था, उसने हीट एडिशन कहा था कि मैं कांस्टेंट टेम्परेचर पे हीट नहीं ऐड करूंगा, मैं तो कांस्टेंट वॉल्यूम पे करूंगा। जब पिस्टन ने कंप्रेस कर दी एयर को, अगेन इन ऑटो साइकिल वर्किंग मीडियम इज एयर, इट इज कार्नोट साइकिल only difference which is coming that heat addition process which was there, he said I won't be doing at constant temperature। मैं तो जैसे ही पिस्टन टीडीसी पे आया, एयर को कंप्रेस कर रखा है, इंस्टेंटेनियसली whatever amount of heat has to be added, instantaneously I'll be adding into that one। suppose 100 kilojoule heat has to be added, उसने कहा कि मैं तो एकदम से इसके अंदर ऐड करूंगा। so heat addition was constant volume, yes। And then expansion, again reversible adiabatic expansion, heat rejection also he said at constant volume I'll be rejecting, मैं टाइम इसमें खराब नहीं करूंगा। हीट एडिशन में और हीट रिजेक्शन में जो टाइम लगता है वो भी एफिशिएंसी को कम करता है। इन द केस ऑफ ऑटो साइकिल हीट एडिशन एंड हीट रिजेक्शन इज ए कांस्टेंट वॉल्यूम। सो कार्नोट साइकिल जितनी एफिशिएंसी तो नहीं है, लेकिन रिमेनिंग साइकिल्स में सबसे ज्यादा अगर एफिशिएंसी है वो ऑटो साइकिल की है, बिकॉज हीट एडिशन और हीट रिजेक्शन में कोई टाइम नहीं लग रहा है उसके अंदर। ये देखो आप, ये अगेन वर्किंग मीडियम वाज एयर, लेकिन हीट एडिशन उसने की, उसने टीडीसी पे की विदाउट कंज्यूमिंग टाइम, और हीट रिजेक्शन भी उसने कांस्टेंट वॉल्यूम पे की। जबकि डीजल इंजन में क्या हुआ, डीजल ने क्या चेंजेस किए, डीजल ने कहा कि मैं कांस्टेंट वॉल्यूम पे हीट ऐड नहीं करूंगा, इट इज रिजल्टिंग इनटू वेरी हाई प्रेशर राइज, yes, rate of pressure rise is becoming very high। so what he has suggested, piston will be moving in downward direction, same time I'll be adding heat in such a way so that during expansion pressure may remain constant। तो डीजल ने जो हीट ऐड किया था वो कांस्टेंट प्रेशर पे किया था। रिजेक्शन वाज एट अगेन एट कांस्टेंट वॉल्यूम, बट हीट एडिशन वाज एट कांस्टेंट प्रेशर। जो रेट ऑफ प्रेशराइज ये दिख रही है अपने को बहुत ज्यादा, यस। सो फॉर रिड्यूसिंग द रेट ऑफ प्रेशराइज ही हैज एडेड हीट एट कांस्टेंट प्रेशर। प्रैक्टिकल इंजन जो आजकल हमारे चलते हैं, जो मैंने बताया आपको कि डीजल इंजन में डिले पीरियड के अंदर फ्यूल इकट्ठा हो जाएगा और जैसे ही कंबशन स्टार्ट होगा वो एकदम से एनर्जी रिलीज करेगा, तो वहां पे हीट रिलीज काय पे हो रही है, करीब करीब कांस्टेंट वॉल्यूम पे हो रही है, एकदम से रिलीज हो रही है ना, इंस्टेंटेनियस। सो एक्चुअल डीजल इंजन्स आर वर्किंग मोर और लेस ऑन ऑटो साइकिल। जो इकट्ठा किया हुआ फ्यूल है वो एकदम से हीट रिलीज करेगा, मींस इट इज नॉट टेकिंग टाइम इन रिलीजिंग द हीट, more or less at constant volume it is adding heat। so practical जो diesel engine है, they are reaching towards this Otto cycle। and in the case of Otto engine, I said spark we are initiating, some chemical delay is there, then slowly flame is propagating, so heat addition which we are doing is slowly heat is being added। so actual petrol engines are reaching towards diesel engine जहाँ पे constant pressure पे heat है। so actual petrol engine में heat addition is becoming more or less at constant pressure, whereas in the case of Otto cycle, in the case of actual petrol engines, diesel engine heat addition is becoming more or less at constant volume। so the cycles which has been devised by Otto, the cycles which has been devised by diesel, actual engines which are working, the diesel engines which supposed to work on diesel cycle, it is working on Otto cycle। the petrol engine which is supposed to work on Otto cycle, actual petrol engine is working on diesel cycle, like this one, like this one। this compression curve from this O point which is there, the A which is there, compression curve is from BDC to TDC, at B it is reaching the air which is being compressed, and the x-axis is the crankshaft rotation, y-axis is pressure। so from A to B air is being compressed and instantaneously heat is being added in Otto cycle। in Otto cycle from B to A heat addition is there and piston is at TDC and the heat is being added, pressure is rising, and after that expansion is taking place। it is theoretical cycle। Otto cycle is theoretical cycle where heat addition is at constant volume, at TDC means 180 degree crankshaft जहाँ पे है, there heat is continuously being added without consuming time। we'll stop here। Professor Pavlaji is there for the purpose of break। just I'll be concluding here whatever we have discussed। two types of engine we have discussed, one we said diesel engine, another one is petrol engine. In the case of diesel, the separate air fuel entry into the cylinder, the instantaneous mixing is there, whereas the petrol engine which we are using, in a plant way mixing was being done. Both the engines are having separate combustion characteristics, their fuels are different, and they're all the characteristics of related to combustion which are there, they are different. Our final always target is that engine running should be smooth, your exhaust emission should be lesser, your thermal efficiency, the important term which you are defined, that is thermal efficiency. Wherever we are saying efficiency, we are saying it is thermal efficiency. Our efforts are to increase the thermal efficiency, and our efforts are to increase the volumetric efficiency. If volumetric efficiency is increasing in a cycle, the amount of air which is entering into the cylinder, fresh air, which is resulting into the improvement in torque. Higher the volumetric efficiency, that we said unit air charge in a cycle, it is improving the torque. And per minute, if amount of air which is entering into the cylinder, if it is increasing, it is increasing the output, engine output, brake power, output in terms of kilowatt, it is increasing. Our targets are to increase the volumetric efficiency, unit air charge, per minute charge which is entering into the cylinder, that we want to increase. And at some times diesel engines are better, sometimes petrol engines are better. We'll be discussing those parameters in remaining time. So thank you very much. Any question? You people are able to listen, every center is able to listen. If some problems are there, please mention.
There is a question, sir. What are the reasons of irreversibility in heat engines?
What are the reasons for irreversibility in heat engines? I conveyed this Carnot cycle to you people, no? Yes, Carnot cycle. In the case of Carnot cycle, if heat addition is at constant temperature and if temperature gradient is negligible, then no irreversibility. If heat source is at a high temperature and the air which is receiving the heat, if temperature gradient is more, the heat when we are giving, the molecules which are receiving the heat from higher temperature, their movement becomes very fast. When their movement becomes very fast, they are striking from each other, it is resulting into lot of losses of power. We want that the temperature gradient between the working fluid and heat source should be minimum, so that the energy which molecules are getting, they should not move rapidly, they not should strike in instantaneously. If they are striking, they'll be losing energy. So one reason for irreversibility is temperature gradient. Another reason is friction between the piston and cylinder. If friction is there, certainly the internal heat generation will be there. Again, it is creating the irreversibility. If heat exchange is there to the surrounding, again it is irreversibility. So heat generation, heat exchange to the surrounding, and heat addition, if temperature gradient is there for heat addition, it is resulting into irreversibility. So these are the three major reasons which is making the cycle irreversible.
What is the role of CFD engine design?
CFD?
In engine design.
Yes, actually fluid dynamics is basically simulating the movement of air inside the cylinder, movement of fuel into the cylinder, and our final target is mixing should be better. Mixing should be means diesel and petrol mixing should be very uniform, and everywhere there is air is there, fuel particle should reach. Otherwise, what happens in some of the areas, air remains, in some of the areas fuel remains. Some of the oxygen which is supplied into the cylinder without taking combustion, it is coming through exhaust, and some of the areas where lot of fuel is there, it is not getting sufficient oxygen for the purpose of combustion, partially unburnt particles in the form of smoke, they are coming out. So CFD is making simulation of movement of fuel and air inside the cylinder in such a way that in every corner the fuel and air is reaching and they are mixing from each other. So basically for the purpose of mixing, CFD is very important.
Sir, is there any software for measuring engine efficiency parameters?
Computer simulation, we have some softwares we can develop now. Softwares are available, in fact, particularly for heat release, particularly for analyzing the pressure theta diagram, P theta diagram. It is getting converted into PV diagram. The mean effective pressure is being calculated. It is calculating the indicated power and fuel supply which we are giving, that we can fix. So on the basis of that one, indicated efficiency can be calculated. For getting friction losses, again empirical relations are there. With the help of that one, friction losses we can find out. So indicated power minus friction losses, it will be giving brake power. So with the help of software, so one is actually experiment we can do. Another one, with the help of softwares we can do simulation, we can compare that one.
what is the difference between knocking and detonation?
Knocking and detonation, more or less it is same. Detonation what we are using if in a constant volume chamber, if you are doing the experiments where air movement is negligible, only constant volume air velocity is negligible, then the spontaneous combustion which is taking place, it is termed as detonation. In the case of engines, normally the term which we are using, it is knocking, where there is a movement of air and volume is continuously varying, because piston is moving inside the cylinder, the volume of air inside the cylinder, it is varying. So the term which we are using knocking, not detonation. Detonation is mainly inside a constant volume and where movement of air is negligible.
Are there any engines working on dual cycle? If yes, how do they practically work?
Dual cycle, your diesel cycle is actually dual cycle. Your diesel engine is dual cycle, where partly heat is being added at constant volume. जो delay period में fuel इकट्ठा हो गया है, जो heat release कर रहा है, it is at constant volume, and remaining fuel after start of combustion, still fuel is getting injected. When piston started to move in downward direction, that burning is more or less at constant pressure. So your actual diesel engines are working on dual cycle, where partly heat addition is at constant volume due to knocking, partly heat addition is at constant pressure. The rate at which fuel is entering into the cylinder, at the same rate burning is going on. So heat addition is in two parts. Practically, if I am saying, around 30% heat is being added at constant volume, 70% at constant pressure. Not 70%, around 50% remaining is when expansion stroke, where pressure is varying. So this varies 30, 50, 20, like that one. 30 constant volume, 50 constant pressure, 20 when expansion after burning, which you are saying in the case of diesel engine.
It is possible to decrease clearance volume in a cylinder. If it is, then what will be the effect?
If clearance volume, if you are decreasing, your compression ratio is increasing. If compression ratio is increasing, in the case of diesel engine, I said we are trying to reduce the compression ratio, because smaller the clearance volume, higher the pressure after compression, and if higher the pressure after compression, starting of the cranking of engine becomes very difficult. प्रेशर अगर कंप्रेशन का ज्यादा होगा तो क्रैंकिंग करना इट विल बी वेरी डिफिकल्ट, एंड इफ क्लियरेंस वॉल्यूम इज लोअर, even the leakage of the gases through the piston rings, it will be much more. So effort should be to reduce the clearance volume. In the case of petrol engine, reduce, but in the case of diesel engine, not much.
How physical delay can be countered?
Physical delay is basically your I said automation, automation, your vaporization, your mixing. इसको अपने को कम करना है, मान लो जीरो करना है. Hypothetically I am saying if physical delay is zero means your viscosity of fuel is very less and its automation is very rapid. आपका थिक फ्यूल होगा, जैसे बायोडीजल्स में आजकल जो दिक्कत आ रही है, बायोडीजल्स आर वेरी थिक, their viscosity is very high, so even automation of those fuels are very difficult. And in small droplets, breaking those fuel particles into small droplets, it's very difficult. So if viscosity is lesser, if fuel is thinner, its vaporization temperature is lower. For the purpose of vaporization, if negligible heat is needed, then vaporization will be easier. So automation is easier, vaporization is easier, and if density is less, then mixing will also be better. If swirl movement of air is significant swirl is there, so even rapidly mixing will be there. So all these three parameters which are affecting the physical delay, if those can be improved, your physical delay will become zero. Even theoretically we can say, if C10 number is 100%, your chemical delay is also zero. Hypothetical situation which where diesel was saying that if delay period is zero, then your heat addition will be at constant pressure. जिस रेट से फ्यूल आएगा वैसे वैसे बर्न होता जाएगा, नो रेट ऑफ प्रेशराइज सिग्निफिकेंट. जिस रेट से आया बर्न होता गया, योर कांस्टेंट प्रेशर विल बी मेंटेन इनसाइड द सिलेंडर. आपका कांस्टेंट वॉल्यूम कंबशन तभी होता है जब फिजिकल डिले इज लॉन्गर, केमिकल डिले इज लॉन्गर. इफ इट इज जीरो, सीटे नंबर इज 100%, दिस डिले इज जीरो, योर हीट एडिशन विल बी एट कांस्टेंट प्रेशर. सबसे स्मूथ चलने वाला इंजन वो होगा जिसका केमिकल और फिजिकल डिले जीरो हो.
Why we want to make the size of valves different in case of petrol engine?
Petrol engine, I said no. In the case of petrol engine, we are starting combustion from spark plug. And spark plug should be the hottest place from where flame is propagating. Yes, more or less the spark plug which we are providing, it is not in the center. Spark plug we are providing towards the exhaust valve side. It's very near to exhaust valve, not to the inlet valve side. We want that flame propagation should start from spark, means very near to exhaust valve, and it should move towards the inlet valve side. If it is moving from inlet valve to exhaust valve and flame is propagating, suppose 30% distance it has covered and 70% still is remained inside the cylinder, that unburnt fuel is available. Where combustion is going on, its temperature will be higher. Where combustion is going on, pressure will be higher. That high temperature, high pressure waves, it will be transferring heat to the unburnt mixture. It is increasing the temperature of that one. And if exhaust valve is also in that region where unburnt mixture is there, that will also adding heat into that unburnt mixture. It will increase the temperature of unburnt mixture and chances of auto ignition will be very high. हम चाहते हैं कि फ्लेम ही सारे मिक्सर को कवर करे, लेकिन अगर एग्जॉस्ट वाल्व बड़ा हुआ आपका और इनलेट वाल्व की साइड से अपन ने कंबशन शुरू किया, तो फाइनली जो एग्जॉस्ट वाल्व जो गर्म है वो अनबर्न्ड मिक्सर को भी गर्म करता जा रहा है. एंड वन सिचुएशन में कम दैट फ्लेम हैज नॉट रीच टू द एंड पॉइंट बिफोर दैट वन. जो एग्जॉस्ट वाल्व की एनर्जी है, जो हीट है, वो उस अनबर्न्ड मिक्सर को एकदम से जला देगा. दैट विल बी रिजल्टिंग इनटू नोकिंग. So we want that spark plug should be located very near to the exhaust valve, so that flame should start from that side. Your inlet valve is the coolest component in the engine. हम चाहते हैं flame hot valve से चल के और cold side में जाए, so that auto ignition it can prevent. And size of exhaust valve we want to reduce so that the heat source, it is heat capacity, in fact M into Cp is heat capacity, MCPT. So if mass is less, so heat stored by that exhaust valve will be lesser, so it will be reducing the knocking.
And why the valve size is same in diesel engine?
In diesel engine, knocking is of different type. No auto ignition problem is there in the case of diesel engine. In diesel engine, we are injecting the fuel, and the knocking which is taking place, it is initial phase of combustion. Very near to injector, the mixture which is available, it is getting auto ignited. It is not near to exhaust valve or inlet valve. So size of inlet and exhaust valve is not important in the case of diesel engine.
So in diesel engines, size of valves are not same. Inlet valve is larger than exhaust valve.
That may be for the purpose of the scavenging purposes, not for the purpose of this combustion. Because in the case of again diesel engine, our target is to increase the volumetric efficiency. हम चाहते हैं कि बड़ा अगर इनलेट वाल्व मिल जाए किसी तरह से अपने को, so more air can come. But the size which is available, even the cylinder head size, suppose 80 mm diameter is there. Out of 80 mm diameter, we'll have to accommodate two valves. We'll have to accommodate injector also. Yes. So space is again a limitation. If larger size inlet valve we are keeping for increasing the volumetric efficiency, then injector will have to have. So size of the valve which will have to accommodate that space which will be available, it will be lesser. So छोटा आपको जो है valve उस केस में रखना पड़ेगा, where volumetric efficiency is the major criteria.
How can we find the octane and cetane number of fuel?
Octane and cetane number we are finding out on variable compression ratio engine. VCR engines we are having where compression ratio can be varied. In the case of petrol engine, here we are comparing with knock intensity. For finding out octane number, knock intensity or pressure variation or noise inside the cylinder is being measured. What we are doing, we are operating the petrol engine, one with fuel of which we want to find out the octane number. उस fuel से चलाते हैं एक बार at some particular compression ratio. ऑक्टेन रेटिंग के लिए कंप्रेशन रेशियो फिक्स कर दिया जाता है. ऑक्टेन रेटिंग के लिए इनलेट जो कूलिंग वाटर का टेम्परेचर फिक्स कर दिया जाता है. आरपीएम ऑफ इंजन हैज बीन फिक्स्ड. एट दैट पर्टिकुलर पॉइंट ऑफ टाइम वी आर सप्लाइंग द एयर प्लस पेट्रोल ऑफ विच वी वांट टू फाइंड आउट द ऑक्टेन नंबर. उस टाइम जो नॉइज इंजन में क्रिएट होती है, दैट वी आर मेजरिंग. वो मेजर करने के बाद वो पेट्रोल बंद कर देते हैं अपन सप्लाई करना. इन प्लेस ऑफ दैट पेट्रोल वी आर सप्लाइंग मिक्सचर ऑफ N-heptane and isooctane. Isooctane is having octane rating 100. N-heptane is having octane rating 0. So that mixture we are supplying, and by trial and error we are changing that mixture, and we are reaching up to that level where same noise which was being created by the sample fuel of which we want to find out the octane rating, ट्रायल एंड एरर से अपन ये रेशियो चेंज करते जाते हैं उस टाइम तक जब तक उतनी आवाज इंजन करना शुरू नहीं कर दे. उस टाइम जो आइसोक्टेन और एन-हेप्टेन का जो मिक्सचर अंदर जा रहा था उनकी परसेंटेज मेजर करते हैं. सपोज 80% आइसोक्टेन इज देयर, 20% एन-हेप्टेन इज देयर, द फ्यूल व्हिच वी आर सप्लाइंग इट्स ऑक्टेन रेटिंग इज 80. मतलब वो मिक्सर उतनी ही नॉइज पैदा करना चाहिए विद सेम ऑपरेटिंग कंडीशन विच द फ्यूल विच ऑफ विच वी वांट टू फाइंड आउट द ऑक्टेन नंबर.
How can we reduce compression ratio at the start of diesel engine?
At the start of diesel engine, for reducing the compression ratio, we can add this जो gaskets है, size of gaskets which we are using between cylinder head and cylinder block. If more gaskets or thicker gaskets if you can provide, your clearance volume can increase.
So how can we differentiate that where the engine is running at overload, underloaded and overloaded?
That with the help of dynamometer. Otherwise it's difficult. And then exhaust, particularly in the case of diesel engine, as overloading is there, the exhaust which is coming out, it is blackish. एक टर्म काम में लेते हैं अपन स्मोक, जिसको स्मोक कहते हैं अपन. स्मोक इज ए कलर ऑफ एग्जॉस्ट. if it is black, which is means exhaust which is coming out, if it is black, it is overloaded. If it is white, engine is cold. If it is blue, some lubricating oil is burning. And if color more or less colorless, it is being operated at part load. If black is there, amount of diesel which you are injecting, it is more. Proper mixing of air and diesel is not taking place because large quantity of diesel is needed at higher load. So if proper mixing is not there, lot of partially burnt carbon particles are coming out in the form of black smoke. In the case of diesel engine, smoke is a serious issue.
Thank you, sir.
No question? हाँ बताओ.
कंप्रेशन रेशियो आप बोल रहे हो जो गैस है उसकी थिकनेस बढ़ा के
हाँ बताओ हाँ यस.
सर उसकी हम उसका साइज नहीं इंक्रीज कर सकते हैं सिलेंडर का, सिलेंडर बोर का, या उसका साइज इंक्रीज कर सकते हैं?
नहीं, ये कह रहे जो इंजन है बना हुआ है अपने बोर वगैरह वो तो बात की बातें हैं. इंजन है उसका अभी अपने खड़े हुए इंजन का कंप्रेशन रेशियो चेंज करना चाहते हैं. जस्ट विल वेरी द गैस्केट्स, है ना. अनदर इंपॉर्टेंट टर्म इज कमिंग एयर फ्यूल रेशियो. In the case of petrol engine, I am saying homogeneous air mixture we are supplying, air fuel mixture we are supplying. And in air fuel ratio, important term is flammability limits. Meaning of flammability limits are if mixture is very rich or mixture is very lean, whatever the source of ignition may be, combustion won't be initiated. Suppose 1 to 1. 1 kg petrol if you are having, 1 kg air we are having, we are making the mixture. Whatever the source of ignition may be, combustion won't be. Minimum air fuel ratio which you like to have for the purpose of this petrol, it should be 8. 8 से कम अगर डेफिशिएंसी होगी ऑक्सीजन की आपकी 8 kg एयर 1 kg फ्यूल के रेशियो से, if it will be lower than that, there won't be any combustion. Another side, if you are going after 20, if 20 kg air is there, 1 kg fuel is there, mixture will be very lean. After that one, if you are having the leanness, if you are maintaining, again I am saying whatever the source of ignition may be, combustion won't be initiated. So your flammability limits normally in the case of petrol engine, it is varying from 8 to 20. 8 to 20 air fuel ratio where combustion can be started, combustion can take place. And in the case of petrol engine, the optimum air fuel ratio which we are having, it is 15. It is chemically correct. If 15 kg air is there, 1 kg fuel is there, it is chemically correct fuel mixture. And the term which we are defining fuel air ratio, it is equal to 5. If phi is 1, air fuel ratio is around 15, or in terms of fuel air ratio, if I am saying 1 by 15. 1 by 15 is roughly 0.068, like that one. So 0.068 fuel air ratio if you are having, then your phi is equal to 1. Phi equal to 1 is chemically correct. If phi is less than 1, it is lean. If phi is say 0.8, 0.7, 0.6, less than 1 phi is lean. If phi is more than 1, it is rich. Say phi is 1.1, it means it is 10% richer than stoichiometric. 10% richer than stoichiometric. If 15 is stoichiometric, 10% richer than 15 is around 13.5. 13.5 air fuel ratio if phi is 1.1 we are saying. So normally terms which are using, either we are using phi or we are using lambda. Lambda is 1 over 5 in terms of air fuel ratio. If you are comparing, it is lambda. In terms of fuel air ratio, if you are comparing with stoichiometric, then it is phi. And even Dr. Khatri yesterday, day before yesterday, he may be discussing about lambda sensor also. Lambda, it is sensing oxygen availability in the exhaust. It is related to your fuel air ratio. It is related to air fuel ratio. Yes, so that lambda sensor is sensing your oxygen contents. We want that in exhaust there should not be any oxygen. In exhaust we want there should be water vapors, there should be CO2, there should be nitrogen. If these are the constituents, then combustion is complete. If there is oxygen, it means the oxygen which is supplied to the cylinder, it has not been utilized. If there is CO, it means availability of oxygen in the combustion chamber was less. That's why CO formation is there. If deficiency of oxygen is there, there will be CO formation. If oxygen is coming out through exhaust, it means whatever air we have supplied for the purpose of combustion, that has not been utilized. तो लैम्डा सेंसर जो है इस चीज को सेंस करता है कि एग्जॉस्ट में ऑक्सीजन है या नहीं है. अगर ऑक्सीजन है तो इसका मतलब वो वहां से रीच करने की कोशिश करता है, ऑक्सीजन की क्वांटिटी को जो है रिड्यूस करता है. इन द केस ऑफ डीजल इंजन, बिकॉज मिक्सचर इज हेट्रोजीनियस, not homogeneity is being maintained. In one particular region we are injecting, and in that region combustion is getting started. So wherever the mixture becomes in the range of 8 to 20, combustion will be started. But all the times diesel engine is working in lean region. Always it is lean. Always air fuel ratio is more than 20. डीजल इंजन हमेशा आपका जो है एक्सेसिव ऑक्सीजन के साथ काम करता है. It is more or less idling. Idling, when I am saying, meaning of idling is when we are waiting on the red light. Engine is in start condition. We are injecting the fuel. No power output we are taking. Vehicle is not moving. Accelerator position is 0. Throttle position is 0. And engine is in just start condition. That position is idling condition. So in the case of diesel engine, in idling air fuel ratio is around 80. Whereas in the case of petrol engine, when idling situation is there, when petrol vehicle is standing on the red light, that time air fuel ratio is around 12.5, 13. Means very rich mixture we are supplying when idling situation is there in petrol engine. But in the case of diesel engine, when we are waiting on the red light, air fuel mixture is very lean, excessive oxygen is available. तो डीजल इंजन आइडलिंग में बहुत कम पोल्यूशन करता है क्योंकि ज्यादा ऑक्सीजन है उसके पास. But in the case of petrol engine, because mixture is quite rich, the exhaust emissions, particularly unburnt hydrocarbons, are quite high. तो idling के टाइम अगर आधे मिनट से भी ज्यादा टाइम हो, particularly petrol engine का कह रहा हूं मैं आपको, please switch off your engine. One, lot of fuel is being consumed because mixture is quite rich. Another one, we are harming the environment to a very high extent. काफी बार आप ऑब्जर्व करना, जो डीजल के ऑटो हैं वो काफी देर तक स्टार्ट कंडीशन में खड़े रहते हैं, दे आर नॉट वरीड एट ऑल. बट पेट्रोल के ऑटो को इमीडिएटली वो बंद करता है. रीजन फॉर दैट वन इज एट द टाइम ऑफ आइडलिंग the consumption of diesel is very low because mixtures are very lean. 80, I am saying 80 to 1, 80 kg air, 1 kg fuel. Whereas same auto when it is working in petrol mode, its air fuel ratio is 12, 12.5, means 12 kg air, 1 kg fuel. So lot of fuel is being consumed for that purpose. So in the case of diesel vehicles in idling, we people are not worried, but in the case of petrol engines, we are severely worried. So air fuel ratio normally in the case of SI engines, it is varying from 10 to 20. 20 is when we are moving on the highways, lean mixture we can supply. It is not exactly 20. It may be 16.5, 17 like that one. And 10 starting means when choke condition is there, that time it is very rich. Otherwise 10, 11, 12. Cruising range which we are having 15, 16. 16.5 up to 17 air fuel ratio in petrol engine is possible. Diesel starting point itself is 18. Minimum air fuel ratio, it is not exactly 18, I am saying 20. Starting point is 20 and it can vary up to 80. तो डीजल इंजन के अंदर एग्जॉस्ट एमिशंस कम होंगे, उसका रीजन ये है कि ऑलवेज एक्सेसिव ऑक्सीजन इज देयर. बट इन द केस ऑफ पेट्रोल इंजन, limited oxygen is there. That's why petrol engines are polluting atmosphere more as compared to diesel engines. दिस इज द रेंज. फ्लेमेबिलिटी लिमिट्स मैंने बताई है आपको जो है टू रिच. अगर 9 से और इधर साइड में आ जाता है, इट इज टू रिच. 30 से आगे वहां पे चला जाता है, इट बिकम्स टू लीन, कंबशन इज बिकमिंग जस्ट इम्पॉसिबल। सो आपकी फ्लेमेबिलिटी लिमिट्स जो है वो करीब 9 से 20 के बीच के अंदर आपकी फ्लेमेबिलिटी लिमिट्स है जहां पे कंबशन हो सकता है पेट्रोल का। ये आपको मैंने प्रीमिक्स और ये बताया था। डीजल इंजन्स आर the two type of governings are there for controlling the speed. One is termed as quantity governing, another one is quality governing. In the case of diesel engine, the amount of air which we are supplying into the cylinder, there is no throttle. Whatever the speed of engine may be, whatever the engine RPM may be, amount of air which is entering into the cylinder, that is constant. According to the load, we are varying the quantity of fuel, and which is being varied by the pump. Engine pump is varying the quantity of fuel. So air fuel ratio is varying in the case of diesel engine. I am saying from 20 to 80 it is varying. So diesel engines are quality governed. Quality means quality of mixture is varying. It is varying from 20 to 80. So quality is being governed. आपको 20 रखना है, 30 रखना है, 60 रखना है, 80 रखना है, that is being done by pump. So these engines are termed as quality governed engines. Whereas in petrol engines, whatever the speed may be, whatever the load may be, the assignment which we are giving to the carburetor, we are saying you operate at stoichiometric. Stoichiometric means 15. Whatever the load condition may be, your air fuel ratio should be around 15. With the help of throttle, what we are doing, we are varying the quantity of air and fuel mixture which is going into the cylinder. We are not varying the air fuel ratio. Air fuel ratio has to be constant. So quantity of air and fuel mixture which is entering into the cylinder, that is being controlled. So petrol engines are termed as quantity governed. Diesel engines are termed as quality governed, means air fuel ratio is being varied. And in the case of petrol engine, quantity of mixture is being varied. Quantity of air in the case of diesel engine is constant. So it is not quantity governed. Here it is quality governed. Air fuel ratio is being governed. In the case of petrol engine, we are controlling the quantity of air fuel mixture which is being controlled. Just one small videos I'll be showing you. About the ignition system in petrol engine, how ignition is taking place, what is the role of spark plug, what is the role of condenser, what is the role of battery, and what is the role of distributor. Just I'll be indicating that one. Your sound is available. Yes. So in the case of ignition system, the components which we are having a battery which is giving either 6 volts or 12 volts. But for initiating the spark across the electrodes, the voltage which we need, it is around 1 lakh volts. So battery volt, that is DC volts which we are having, that 12 volts will have to enhance up to 1 lakh volts for the purpose of initiation of spark. It is having the spark plug is having 2 electrodes, which it was showing that spark in between electrodes it was showing, and in between those 2 electrodes we are having air fuel mixture. We have compressed the air fuel mixture. That mixture is between electrodes also. So for the purpose of initiation of spark, in between we are having air. Air is a very bad conductor of electricity. So first of all, if you want to initiate the spark, the ionization of air has to be. If ionization will be there, then only current can flow across those electrodes. So initially when 12 volts is coming, it is passing through a circuit. Your contact breaker is in closed position. If it is in closed position, through that circuit electricity will be passing and it is grounded. So no spark will be produced. In primary circuit, there is a contact breaker. If contact breaker breaks, when cam was rotating, you have seen here one cam of 4 lobes, because 4 cylinders are there, 4 lobes are there. When that lobe is breaking the contact, it means in primary circuit current becomes 0. जैसे break होगा आपका circuit, in primary circuit current becomes 0. If current becomes 0, then rate of change of current in primary circuit, it is di by dt. Suppose initially some 4 amperes current was flowing, and now when contact breaker it has broken the circuit, it has become 0. Current which was flowing, it has become 0. So di has become 4. So di by dt, it will be having some rate of change of current in the primary circuit. When there will be rate of change of current in primary circuit, immediately according to the number of turns in secondary coil, the voltage, high voltage will be induced. कब इंड्यूस होगा? जब प्राइमरी सर्किट कॉन्टैक्ट ब्रेकर की हेल्प से ब्रेक होगा. when it will be broken, then there will be rate of change of current in the primary circuit, and when there will be rate of change of current in primary circuit in secondary coil, which is having number of turns, very high number of turns. So according to number of turns, very high voltage will be induced in the secondary coil, and that secondary coil is through distributor, it is connected to spark plug of one cylinder. Okay, so that very high voltage will be going to spark plug, and I am saying for the purpose of initiation of spark, because air is there, it is having very high resistance towards the electricity, so ionization is required. once ionization is there, the spark is not for just negligible time, it is for a finite time. Spark is continuing for finite time. So initial requirement will be very high voltage. Once air has been ionized, your spark will be continuing. Spark will be continuing. Even voltage may go down till your your contact breaker is in open position. Contact breaker is also open for finite time. So till contact breaker is in open position, the high voltage is passing through the secondary coil to spark plug, and spark will be continued. Even the energy level, once spark has gone to spark plug, initially I said requirement will be very high, but once air has been ionized, even lower voltage will be able to continue the spark. Whatever energy has been transmitted from primary to secondary coil, that energy initially it will be very high, then decay will start. Even voltage at spark plug will be going down. Even it may come up to 5000 volts. When it becomes very low volts at spark plug and your contact breaker is in open position, at that lower voltage spark won't be able to continue. वहां पे spark जैसे ही आपका spark plug में spark बंद होता है, so secondary coil में current आपका जीरो हो जाता है. Otherwise it was grounded, means through spark plug it was grounded. Secondary coil circuit was completed. But जैसे ही कम voltage होने से spark plug में spark बंद होता है, in secondary there will be rate of change of current. When there will be rate of change of current in secondary, that will try to induce back EMF into the primary coil. Yes, and in primary coil is connected through contact breaker. तो अगर प्राइमरी में हाई वोल्टेज इंड्यूस होगा अकॉर्डिंग टू द नंबर ऑफ टर्न्स व्हिच इज इन द प्राइमरी, तो वो आपके हाई वोल्टेज कॉन्टैक्ट ब्रेकर के अक्रॉस, कॉन्टैक्ट ब्रेकर अभी भी खुला है, इट विल ट्राई टू जंप अक्रॉस द कॉन्टैक्ट ब्रेकर, तो कॉन्टैक्ट ब्रेकर की लाइफ कम कर देता है. टू अवॉइड दैट वन वी आर पुटिंग ए कंडेंसर इन द सर्किट. प्राइमरी सर्किट के अंदर एक कंडेंसर लगाते हैं. वो क्या करता है कि जैसे ही सेकेंडरी में रेट ऑफ चेंज ऑफ करंट होता है तो वो उसको स्टोर कर लेता है एनर्जी को, एंड दैट स्टोर्ड एनर्जी जैसे ही वो कॉन्टैक्ट वापस क्लोज होता है नेक्स्ट साइकिल के लिए, दैट एनर्जी विल बी यूटिलाइज्ड इन द प्राइमरी सर्किट फॉर बिल्डिंग अप द वोल्टेज. आजकल आप लोगों ने नाम इलेक्ट्रॉनिक इग्निशन सिस्टम का भी सुना होगा. इन इलेक्ट्रॉनिक इग्निशन सिस्टम व्हाट दे आर डूइंग, just to avoid the spark across the contact breaker, they are putting one transistor in the system. Transistor is a one way valve. ये एक साइड में ही वोल्टेज को जाने के लिए अलाउ करता है प्राइमरी से सेकेंडरी में, बट फ्रॉम सेकेंडरी टू प्राइमरी व्हेन इट इज बीइंग इंड्यूस्ड इन रिवर्स डायरेक्शन अक्रॉस द कॉन्टैक्ट ब्रेकर इट वोंट परमिट. तो आपके कॉन्टैक्ट ब्रेकर के अक्रॉस जो स्पार्क नहीं होगा एंड लाइफ ऑफ कॉन्टैक्ट ब्रेकर इज इंक्रीजिंग. एंड अकॉर्डिंग टू फायरिंग ऑर्डर द स्पार्क इज बीइंग प्रोड्यूस 1 3 4 2. पहले एक में होगा, फिर 3 में होगा, फिर 4 में होगा, फिर 2 में होगा. And the advertisements which are being given that cost of this vehicle is much more because it is having electronic ignition system, it is bit misleading. When we are making this electronic ignition system, the components which you are adding, very cheap components. Your transistor may be costing some 10 rupees, your diode which you are putting say 1 rupee cost. So those components we are putting and we are making electronic ignition system. So electronic ignition system is basically increasing the life of the contact breaker and build up voltage, because most of the engines these days which are working, they are working at a very high speed. So in primary circuit immediately voltage has to be built up for the next cycle. So in building up this electronic ignition system is helping. So that is electronic ignition system. This already we have explained. The two curves you can observe from here. One is continuous line, another one is dotted line. These two lines are different. It is I'm showing for spark ignition engine. These two lines are different. The difference between these two is dotted line is just compression of air or compression of air fuel mixture in petrol engine. No spark we are giving, and just we are expanding that mixture without combustion. Suppose air fuel mixture we have taken into the cylinder, we have compressed that one, but no spark we are initiating. Just again we are expanding back, and finally it is going to exhaust. And then the pressure variation inside the cylinder if you are observing, if you are measuring the pressure variation. So a dotted line ये दिखाती है अपने को, फर्स्ट ये फर्म लाइन है, उसके बाद TDC के बाद आने के बाद ये डॉटेड लाइन आगे एक्सपांड होती है. दिस कर्व इज टर्म्ड एज मोटरिंग कर्व. दिस इज टर्म्ड एज मोटरिंग कर्व. नीचे वाला जो कर्व है इट इज मोटरिंग कर्व. कुछ लाइन कुछ बी तक तो ये सेम ही है. Starting from that side some 90 degree before TDC to TDC the curve is same. After that one just we are expanding that air fuel mixture. This is motoring curve, means without combustion if expansion of air fuel mixture is taking place, it is motoring curve. In contrary to this one, if you are producing a spark at point A, if you are producing the spark and that spark we are producing before top dead center, हम जो spark produce करते हैं वो TDC से पहले करते हैं, and actual combustion is getting started at B. At A we have started, still crankshaft is rotating, piston is moving in upward direction toward TDC, but combustion has not been started. अगर combustion start हो जाता तो motoring curve से वो curve deviate हो जाता, प्रेशर वेरिएशंस वही आ रहे हैं जो कंप्रेशन की वजह से आ रहे हैं, न कि कंबशन की वजह से आ रहे हैं। एट पॉइंट बी योर इग्निशन लैग पीरियड विल बी कंप्लीटेड। जो केमिकल रिएक्शंस थी ना, ए पे अपने स्पार्क किया, देन सम केमिकल रिएक्शंस हैज बीन इनिशिएटेड, एंड एट पॉइंट बी योर एक्चुअल कंबशन हैज बीन स्टार्टेड। सो फ्रॉम बी टू सी flame will be propagating inside the cylinder. So B to C आपका main combustion period है, and A to B is ignition lag. So first phase of combustion is ignition lag, from B to C is flame propagation. जिस जगह पे अपना पीक प्रेशर आ जाता है साइकिल का, जिस जगह पे पीक प्रेशर आ जाता है उसको मान लेते हैं अपन कि करीब 90% बर्निंग हो गई है, आपका फ्लेम प्रोपगेशन कंप्लीट हो गया है। जो टोटल फ्यूल अपने सप्लाई किया था at C we are assuming that 90% fuel has been burned, the flame propagation has been completed. Then after that C to D, piston is from TDC it is going down up to C, pressure was increasing, even piston started moving downward direction, pressure is increasing due to combustion, it is increasing. After that on C to D your pressure has also started to decrease, but still some combustion is taking place. Whatever is left inside the cylinder, कहीं पे भी क्वेंच एरिया में साइडों में जो भी मिक्सचर बच गया है अपना सिलेंडर वॉल्स के आसपास, दैट इज कंटिन्यूसली बर्निंग, दैट इज टर्म्ड एज आफ्टर बर्निंग। हम लोग हमेशा ये चाहते हैं, ये कंबशन की स्टेजेस बताई ना आपने, फर्स्ट मैंने बताया A to B इग्निशन लैग, B to C फ्लेम प्रोपगेशन, अप टू 90% मिक्सचर विल बी बर्निंग, एंड C to D इज आफ्टर बर्निंग, वेरी लिमिटेड मिक्सचर विच इज अवेलेबल इनटू द सिलेंडर, दैट इज बर्निंग। अब आपका A पे आपने स्पार्क किया था, कंबशन आपका D पे खत्म हुआ। A to D अगर नंबर ऑफ डिग्रीज देखो क्रैंकशाफ्ट की, करीब -20 से शुरू हुआ था एंड इट इज कंप्लीटिंग समवेयर अराउंड 40, तो कंबशन ड्यूरेशन आपका करीब 60 डिग्री का क्रैंकशाफ्ट के रोटेशन के टाइम हो गया। -20 पे जब TDC पे जा रही थी पिस्टन तब शुरू हुआ था कंबशन, स्पार्क वे प्रोड्यूस्ड, बट एंड ऑफ कंबशन इज आफ्टर TDC, so it has taken time. But in the case of Otto cycle, what we were saying, in the case of Otto cycle we were saying heat addition is at constant volume, but here volume is not constant. In actual engine, in actual petrol engine, when we are discussing the combustion, it is not constant volume, your volume is varying, your piston is moving, but still combustion is going on. For getting maximum efficiency, we want that combustion should be at constant volume, तब आपको एफिशिएंसी सबसे ज्यादा मिलेगी। पर अगर कांस्टेंट वॉल्यूम पे ये कंबशन हो जाता, मीन सारा फ्यूल एक साथ ही बर्न हो जाता, सो रेट ऑफ प्रेशराइज इनसाइड द सिलेंडर वुड हैव बीन वेरी लार्ज एंड देयर वुड हैव बीन सीवियर नॉकिंग। तो जितना लंबा आपका ड्यूरेशन होगा कंबशन का, आपकी नॉकिंग कम हो जाएगी, बट पीक प्रेशर्स विल बी लोअर। If instantaneous combustion is there, peak pressure will be very high. If slowly combustion is taking place, your peak pressures are lower. If peak pressures are lower, your thermal efficiency of the engine will be lower. अगर नोकिंग करेंगे आप तो नॉइज तो होगी लेकिन एफिशिएंसी बढ़ जाएगी। अगर नोकिंग नहीं हो रही है, रेट ऑफ प्रेशराइज ज्यादा नहीं हो रहा है, तो आपका स्मूथ रनिंग तो इंजन की है, बट योर एफिशिएंसी इज गोइंग डाउन। द स्पार्क टाइमिंग एट ए, किस जगह पे अपन स्पार्क करें, अपन टीडीसी से कितना पहले स्पार्क करें, इट विल बी डिसाइडेड दैट वेयर वी वांट सी, आपका पीक प्रेशर कहां पे आए। पीक प्रेशर अपन चाहते हैं कि टीडीसी से करीब 7 से 8 डिग्री बाद में आना चाहिए। For optimum engine operation, we want that peak pressure which is coming inside the cylinder, it should come after TDC. जब आपका पिस्टन नीचे आना शुरू हो गया है, उसके 7-8 डिग्री बाद में आना चाहिए। Those timings are being specified by the manufacturer. मैन्युफैक्चरर जो अपना मैनुअल देता है, उसके अंदर एक टाइमिंग डिफाइन करता है कि स्पार्क टाइमिंग ऑफ दिस पर्टिकुलर इंजन इज दिस वन, एंड वो आइडलिंग के लिए करता है। जब अपन कई बार मैकेनिक के पास जाते हैं, उसके पास एक टॉर्च भी होती है, एक लाइट डालता है वो इंजन पे, वो लाइट से ये पता करता है कि किस एंगल पे स्पार्क हो रहा है आइडलिंग पे। जस्ट वो व्हीकल तो चल नहीं रहता, इंजन स्टार्ट कंडीशन में होता है, दैट टाइम इज मेजरिंग द टाइमिंग्स। दीज टाइमिंग्स आर विच आर गिविंग पीक प्रेशर्स slightly after top dead center, 7 to 8 degree top dead center. These timings are termed as MBT timing, MBT, minimum advance for best torque. these timings are minimum advance for best torque. The peak pressure which you are getting, if it is coming slightly after top dead center, the torque which will be getting from the engine, that will be maximum. That will be maximum. In contrast to this one, if A is shifted towards left hand side, A को मैं left hand side में इस side में लेके जाऊं, left hand side में, away from TDC if I am doing, it means I am advancing the spark. Spark advance means if A is shifted towards left hand side, if A is shifted towards TDC side, right hand side, it is termed as retarding of spark timing. Advancing and retarding we are saying. I think you people are getting this one. This A to B timing is variable. It is not constant. It depends upon engine speed. Higher the engine speed, your ignition lag period we are measuring either in terms of theta or in terms of time, absolute time. एक की अप्रोच हो सकती है कि मैंने स्पार्क किया और मैं घड़ी लेके बैठ जाऊं, कि स्पार्क करने के बाद एक्चुअली कंबशन कब शुरू हो सकता है, मिली सेकंड में टाइम मेजर करूं मैं. वन अप्रोच में भी. Another approach may be I am measuring the theta, that how many degrees crankshaft has been rotated from the point of start of spark to point where combustion has been initiated. So in terms of theta I can measure, and in terms of time I can measure. In the case of petrol engine, when we are operating engine at say 2000 rpm in one case, another case we are operating at 4000 rpm, the B to C total combustion duration is starting from A, more or less it is ending at C. Your B to C time in terms of millisecond, B to C in terms of millisecond, it remains constant, whatever the speed may be. In terms of millisecond it remains constant, but the chemical reactions which are there, A to B, in terms of milliseconds it won't remain same. Same means मैं कहूं कि B to C आपका अगर क्रैंकशाफ्ट 40 डिग्री रोटेट कर रही है 2000 आरपीएम पे और 1 मिलीसेकंड टाइम लग रहा है, नाउ स्पीड ऑफ द क्रैंकशाफ्ट हैज बिकम से 4000 इन प्लेस ऑफ 2000. the time in terms of millisecond in place of 1 millisecond, now it will become half. जो आपका B to C टाइम है, जैसे स्पीड बढ़ती जाएगी, फ्लोएम प्रोपगेशन स्पीड्स becomes faster because lot of turbulence inside the cylinder will be and flame will be moving rapidly. So in terms of millisecond, if RPM is increasing from 2000 to 4000, in terms of millisecond, earlier at 2000 millisecond time from B to C was suppose 1 millisecond, now RPM has become 4000. Now from B to C in terms of millisecond time will become half millisecond. तो क्रैंकशाफ्ट के रोटेशन उस टाइम में कितने हो जाएंगे, जब 2000 पे रोटेट कर रहा था, क्रैंकशाफ्ट के रोटेशन मान लो 40 हो रहे थे. Now speed has become doubled, 4000. So in millisecond now it won't be rotating 40 degree, it will be rotating in 1 millisecond 80 degrees. लेकिन अब क्या हो गया कि in terms of time जो है वो आधा हो गया है. So still whatever the speed may be, in terms of crankshaft rotation it will remain same. एक से जब आधा हो गया तो आपके क्रैंकशाफ्ट के एंगल भी जो है डबल हुआ था वो आधा हो जाएगा, मतलब 80 होना चाहिए था 1 मिलीसेकंड में, मिलीसेकंड हैज गॉन डाउन टू हाफ, सो इट हैज बिकम 40. सो यहां तो 40 रहेगा आपका, लेकिन A to B टाइम जो है, केमिकल रिएक्शन का टाइम जो है, इन टर्म्स ऑफ मिलीसेकंड मोर और लेस इट रिमेन सेम व्हाट एवर द स्पीड. वहां तो हाफ हो गई, B to C तो हाफ हो गया, स्पीड जैसे डबल हुई, बट A to B व्हेन स्पीड हैज बिकम डबल्ड इन टर्म्स ऑफ मिलीसेकंड इट विल रिमेन कांस्टेंट. सो इन टर्म्स ऑफ थीटा क्या हो जाएगा, if it in terms of millisecond remains constant, if speed has become doubled, so in terms of theta उतने टाइम में क्रैंकशाफ्ट क्या होगी, ज्यादा रोटेट कर जाएगी, ज्यादा रोटेट कर जाएगी. तो एट सेम पॉइंट यू आर गिविंग स्पार्क एट 4000 आरपीएम, तो कंबशन आपका कहां शुरू होगा, बी किधर शिफ्ट हो जाएगा आपका, राइट साइड, लेट हो जाएगा ना, लेट हो जाएगा, लेट हो जाएगा तो आपका पीक प्रेशर सी आएगा, वो भी लेट हो जाएगा. इफ इट विल बी डेविएटेड, अपन ने कहा था द ऑप्टिमम टाइमिंग्स आर व्हेन सी इज कमिंग समवेयर 5 to 6 डिग्री आफ्टर टॉप डेड सेंटर, but due to increase in speed that C has gone away, it means output of engine will go down. आपका peak pressure भी कम हो जाएगा, जैसे दूर जाता जाएगा peak pressure will be going down. So when we are increasing the speed, what we'll have to do, what precaution we'll have to do so that C should remain at the same point, what we'll have to do, A will have to शिफ्ट अर्लियर, एडवांस करना पड़ेगा अपने को, ताकि ए एडवांस करके बी वहीं पे आ जाए, because in terms of theta it has been increased, in terms of millisecond it remain constant from one A to B, speed has gone up, so A should shift towards the left hand side, so A to B it can increase, but B to C it should remain same. So C point is fixed, A is varying. So your starting point of spark when speeds are increasing, it is changing, but the point at which combustion is getting completed, that will remain same. So always your MBT timing which you are fixing, that minimum advance for best torque, it is fixing only at idling. As speed of the engine we are increasing by varying the throttle position, this spark at which the point at which spark is taking place, it is getting away from TDC. It is getting quite away from TDC. It is termed as advancing of the spark timing. इसके मैकेनिकल मैकेनिज्म है, वैक्यूम से है, many controls are there, electronically it is being controlled, but spark timings are continuously varying. This burning which is being taken place, continuously flame is propagating, either it is propagating spherically or it is propagating cylindrically. When it is propagating, always chances are the unburnt mixture, one is burning is taking place from one side, remaining is unburnt mixture, towards that unburnt side lot of heat is getting transferred, और ऐसे होते होते ये हो सकता है कि अनबर्न्ड मिक्सर का टेम्परेचर भी 450 से ज्यादा हो जाए. The self ignition temperature of petrol is 450 degrees Celsius. Without reaching the flame, unburnt mixture will be heated up to the temperature, up to self ignition temperature more than 450 degrees Celsius. There are chances that this mixture can auto ignite. Yes, and the auto ignition of this one is termed as knocking. So if you have heard, if you have seen on the petrol pumps, it is written unleaded petrol is available. Meaning of unleaded and leaded petrol was before 2001 lot of lead was being added into the petrol, and purpose of lead was to increase the chemical reactions time. Increasing of chemical reaction times means even your petrol has reached to 450 degrees Celsius at its SIT, but its combustion won't start. अगर ऐसा कर दें कि पेट्रोल 450 पहुंच भी गया हो अपने इग्निशन टेम्परेचर पे, लेकिन ये बर्न होना शुरू नहीं हो, means chemical reactions which has to be completed at that SIT temperature, that time is getting longer by adding this lead into that one. lead जो ऐड करते थे अपन ऑक्टेन रेटिंग बढ़ाने के लिए, मींस केमिकल रिएक्शंस को वो स्लो कर देता था. कई बार आप लोगों ने देखा होगा कि लोग अंगारों पे से चले जाते हैं, गर्म अंगारे होते हैं उस पे से लोग निकल जाते हैं, and their skin is not getting burned. Reason for that one is the skin needs some particular temperature for the purpose of burning, and not only temperature, it has to be maintained at that temperature, then only burning is taking place. So आदमी जो अंगारों पे से चल रहा है, the contact time, if it is less than the chemical reactions time, there won't be any burning. Burning of the skin only will be if it is getting maintained at that particular temperature for that particular time, then only आपकी burning होगी skin की. Even inside the cylinder you observe the peak temperatures which are coming, these are around 2000 degrees Celsius, and your cylinder is made with cast iron. The melting temperature of cast iron, upper critical temperature, it is around 1147, 1150 होता है. Combustion temperature I am saying reaching to 2000 degrees Celsius. Your cylinder material is cast iron where melting has to be at 1150, 1147, but कभी मैंने कोई भी सिलेंडर को आज तक मेल्ट हुए नहीं देखा है. It is not getting melted. Reason is even temperature has reached higher than the melting temperature, but for the purpose of melting, that temperature has to be maintained for some particular time, then only the reactions which are there for the purpose of melting, those reactions will be completed. अगर वो रिएक्शन कंप्लीट होने से पहले अगर टेम्परेचर कम हो गया 1147 से, आपका 2000 से लेस आ गया, एंड केमिकल रिएक्शन हैज नॉट बीन कंप्लीटेड, नो मेल्टिंग विल बी देयर. सेम इज द केस with avoiding detonation knocking. If heat is getting transferred continuously, even temperature has reached to 450 degrees or more than that one, but if chemical reactions which are to be completed for start of combustion, if those reactions has not been completed, no auto ignition will be there. So lead which was being added, it was basically for elongation of chemical reactions. 2000 के अंदर सुप्रीम कोर्ट पिक्चर में आया, उन्होंने कहा ये लेड तो बहुत टॉक्सिक है, लोगों के ब्लड में जा रहा है, ब्रेन हेमरेज हो रहे हैं. चिल्ड्रन का ITO सर्किल दिल्ली में काफी सर्वे किए गए, एंड मेनी ऑफ द स्मॉल चिल्ड्रन वर सफरिंग फ्रॉम दिस लेड कंटेंट्स. Lead is not taking part in combustion. It is coming, just it is one additives which is enhancing the chemical reactions time, but it is not taking part in combustion. Solid lead was coming into the atmosphere. It was getting settled on some eatables, some fruits, some vegetables. Those fruits, eatables we were taking, and those lead contents were mixing with our blood. Blood is getting circulated from heart to brain, and the nerve system which we are having, which is circulating this blood, it is very thin. So the lead particulate which has been added into our blood, they used to settle into our nerve system, and chances of brain hemorrhage due to those lead contents was very high. That's why Supreme Court in 2001 they said you ban this leaded petrol. और आज भी इवन मैं आपको कह रहा हूं कि इंडिया के अंदर एक भी ड्रॉप पेट्रोल का ऐसा नहीं है जो अनलेडेड हो. This unleaded term is misleading. Only the lead contents have been reduced. Up to 2001, the amount of lead which was being added, that was roughly 0.13 grams per liter of petrol. Now it is say 0.012, like that one. So it has been reduced, but not a single droplet is available which is unleaded. But the purpose of lead which was being added, it was for increasing the chemical reactions. Now in 2001, when Supreme Court said that you please remove this one, then some alternative has to be. For some specific reason it was being added. So what should be the alternative? So immediately refineries came into picture. They have started to add benzene into this one. Around 6% benzene they were adding. Benzene is aromatic group, ring structures. And in the ring structure, fuels are having higher octane rating. Their chemical reactions times are longer. So around 6% aromatics were being added into this one. Benzene add karna shuru kar diya. But problem with benzene was the vaporization of benzene is very rapid. When we are purchasing petrol from the petrol pump, your fuel tank is vented to atmosphere. So lot of vaporization at the time of purchasing, because it was being mixed into the petrol. There from the fuel tank it was being vaporized, from the carburetor it was being vaporized. So in the atmosphere, lot of hydrocarbons has started to be added. So one side we have started to reduce the lead, but another side the benzene, when we were adding, lot of hydrocarbons were being added into the atmosphere. So still it was a question that the lead was better or this benzene is better. Again Supreme Court came into picture. They said you reduce the benzene quantity. At present around 1% benzene is being added, and small quantity of lead is available for maintaining that 90 octane number. Now this is burnt and unburnt, I am sure. Burnt and unburnt. First one, first the circle which is there from B to D, flame is continuously propagating, no auto ignition is there. But in second one between C and D, auto ignition is taking place. Rapidly auto ignition, that is knocking tendency. And in P theta diagram also there is variation in the pressures. Wherever there is variation in pressure, it means engine is knocking. And slightly this knocking is preferred. Even in Maruti, this knocking is permitted. They are saying knocking means constant volume combustion, rapid combustion. If rapid combustion is there, your fuel efficiency is increasing, thermal efficiency is increasing, means average of vehicle is increasing. कुछ नॉइज तो होती है, और कई बार आप देखना जब गाड़ी लोड में होती है, सेकंड गियर थर्ड से सेकंड में टाइम पे नहीं ला पाए, तो कुछ different type of noise is taking place. That noise is also the knocking inside the cylinder. So manufacturer intensely adding this knocking for the purpose of increasing the fuel efficiency in some of the cases, in some of the engines. ये आपके combustion का जो propagation है flame का, somewhere I shown that 90% burning acid A, B, C I shown here, may not be very important. Then combustion quality, combustion durations, duration of combustion. In the case of petrol engine, it is around 40 to 50 degrees Celsius. In diesel engine, it is around 100. Diesel engines are less efficient as compared to petrol engine as far as their thermal efficiency is concerned. Reason for that one is, in diesel engine combustion duration is longer. In petrol engine combustion duration is 45 to 50 degree of crankshaft rotation. In the case of diesel engine, it is more than 100. Longer the combustion duration, we are deviating from constant volume combustion. When you are deviating from constant volume combustion, longer the combustion duration, your peak pressures are going down, your thermal efficiency is decreasing. Yes. कुछ आपके फ्यूल एयर रेशियो वगैरह जो अफेक्ट कर रहे हैं, इंजन की एफिशिएंसीज को अफेक्ट कर रहे हैं. ये मोटे कुछ मैं बीच में आपको एक दो वीडियो और दूसरे में दिखाना चाहूंगा. जस्ट आई विल बी स्विचिंग ओवर टू दिस वन अगेन. आई विल बी कमिंग टू दैट. Some more videos I wanted to show you. Just I'll be coming to this point. Yes, from this point I'm coming. The combustion we have seen. From a given size of engine, our target is we want to obtain highest possible output. First target, from a given size of engine, your output should be maximum. Another target which we want to have, thermal efficiency of the engine should be maximum. Third one, we want engine operation should be smooth, आवाज नहीं करे. And fourth one is exhaust emission should be minimum. Four are the major requirement. One, output should be maximum. Another one, fuel consumption should be minimum. Third one, noise should be minimum. And fourth one, exhaust emission should be minimum. That exactly we want. Yes. सबसे पहले जब ये 1893 में इंजन बनने शुरू हुए थे, आप देखिए 0.7 bhp इंजन के लिए जो सीसी चाहिए होती थी वो करीब 1000 सीसी थी. And now 1000 cc your cars which you are having, roughly how much output is there? Around 50, more than 50 horsepower. 1000 से even 150 horsepower भी 1000 cc से मिलता है. And that time when we started the engines in 1893, 1000 cc engine used to give 0.7 bhp. So this we want, from a given size of engine we want more and more output should be there. Mercedes ने जो सबसे पहले गाड़ी बनाई थी 1901 में, yes, ये 35 horsepower की थी और इसका इंजन का साइज जो 6000 cc था. 6000 cc used to produce 35 hp. yes, and इसकी स्पीड होती थी 35 किलोमीटर पर आवर की स्पीड से ये गाड़ी चलती थी. आजकल की गाड़ियां देखो आप, ये लास्ट कॉलम देखो आप, और कोई नहीं देखिए. 172 with 1 liter, 1 liter is 1000 cc. with 1000 cc the output which you are getting, brake power which you are getting, brake power को कई जगह ps भी लिखा हुआ होता है. ps is German term, in fact German ps and this horsepower is same. The power which is written in PS and it is German, it is same. So 1000 cc 1 liter engine is producing 172, and what was producing earlier 0.7 bhp. So our target is, from a given size engine the output should be maximum, and it is termed as power to weight ratio. It is termed as power to weight ratio. Power to weight ratio of an engine of a vehicle should be maximum. Power ज्यादा मिले, आपका इंजन का मास जो है, वेट आपका कम से कम होना चाहिए. And for increasing the power output, I am saying your volumetric efficiency should be higher, your compression ratio should be quite high, the air which you are supplying, it should be utilized, means no excess air, and whatever air we are supplying, its proper utilization has to be. Just this video I wanted to show you related to volumetric efficiency.
The AEM Infinity ECU is legal in California only for racing vehicles, which may never be used upon a highway. DE stands for volumetric efficiency, which is essentially how well the engine is using its cylinder volume. We've all heard the saying that an engine is an air pump, and that's completely the case. What we use that pump for is to extract the chemical energy in a gasoline and turn it into horsepower. Volumetric efficiency is how well that engine does it per its given displacement. You don't increase performance by throwing more fuel at it or less fuel at it. You increase the performance of an engine mostly by increasing how much air is moving through it.
So if you've got an engine with upgraded camshafts, an engine with different cams is going to flow more air at certain RPMs than an engine with stock cams. And it actually may flow less air at other RPMs. It becomes more or less efficient at moving air when you change things like camshaft intake runners, like on the intake manifold, exhaust runners and exhaust pipe diameter.
All these things are about moving air through the engine. Volumetric efficiency is just how efficient is the engine at packing those air molecules into that volume.
The higher the VE, the more efficient the engine is, the more air it's moving. Thus, it's making more power. You'll notice many times that your VE table looks a lot like your dyno graph, and that's no mistake. The more air you're moving, the more torque you're going to make. And a lot of times at peak torque, you're going to be right around 100% VE, and that's no bonus.
Unlike pulse width-based systems, VE systems use airflow as their primary foundation. If you know your airflow, injector size, and target AFR, then a VE-based system like the Infinity will automatically determine how much fuel is required at any RPM under any condition. What this means is that once you set that VE table, you can forget about having to make fuel corrections. This will speed up your tuning time and lead to a host of other tuning advantages. For more information, visit amelectronics.com.
Yes, for increasing power output, we need volumetric efficiency should be quite high. Higher the volumetric efficiency, higher the power output. And these are some of the formulas of volumetric efficiency. And engines are very, very sensitive as far as volumetric efficiency is concerned, particularly in diesel engine. The work which I have done, my work was on diesel engines. I did my PhD from IIT Delhi, and I was working on diesel engine, 5 horsepower engine I was working, and I worked for dual fuel engines. In suction I was giving LPG, and for start of combustion I was injecting the diesel into that one. So I've observed sometimes even small obstruction in the intake manifold, or slightly if your valve is leaking, particularly your exhaust valve may leak. If it is leaking, so at the time of compression some of the air may go out. If valve is leaking, even it is in closed position, but some of the air may go out. Engine efficiency, thermal efficiency, normally if you are getting say 26%, if slightly valve is leaking, it may become some 17%, 18%. Means deterioration of engine operation is very severe if change in volumetric efficiency is very little variation is there. Huge change in engine output is coming, huge change in engine efficiency is coming. So foremost part in an engine operation is its volumetric efficiency. Always efforts has to be made to this volumetric efficiency, चाहे वाल्व को बड़ा करके, चाहे जो obstruction कम करके, चाहे friction कम करके, whatever the method may be, volumetric efficiency has to go up. ये वाल्व टाइमिंग भी आप लोग देखते हैं. Valve timings, theoretically valve has to be open at TDC, it has to be closed at BDC. Even exhaust valve has to be open theoretically at BDC, it has to be closed at TDC. But for giving more time, and not only more time, for the purpose of opening of the valve, mechanically some time is needed. Instantaneously we can't open up the valve because it's a mechanical component. So we want that inlet valve should be opened completely at TDC. So exactly at TDC we can't open. We'll have to start before that one because it is taking time for the purpose of opening. So there are mechanical reasons, and even closing which we are doing exactly at BDC we can't close. Because slowly we'll have to close. Otherwise there will be between cam follower there will be detachment, and they may separate out. So slowly we'll have to close them, slowly we'll have to open them. So your opening of inlet valve is start before TDC and closing is आफ्टर बीडीसी. अगर क्लोजिंग टाइम में थोड़ा सा ही फर्क हो गया आपका, आपने वाल्व प्रॉपर सेट नहीं किया, आपने सीवियर चेंज इन वॉल्यूमेट्रिक एफिशिएंसी इज कमिंग. सो ये वाल्व टाइमिंग भी आपके जो अपन करते हैं या मैन्युफैक्चरर देता है, एंड विशेष रूप से ये वाला जो है, this part if you see, this one, the rocker arm and the valve stem which we are having, and there is a gap, that is termed as tappet clearance between these two. If tappet clearance is larger, the rocker arm will be touching this valve stem, means it will take time to fill up that gap and for pushing. If that gap is smaller, immediately it will be touching to that one. So even the small change in gap will be affecting volumetric efficiency very high. So in the case of diesel engine, volumetric efficiency, particular diesel engine I am saying because I worked practically on that one, years I worked on that one. So effect of these timings are very severe on volumetric efficiency, and effect of volumetric efficiency on power output, exhaust emission, smoke is again very serious, very severe. This is scavenging period. With the help of fresh mixture, if you are exhausting the burnt products, that is again increasing the volumetric efficiency. Our target initially I said we want that no burnt product should be inside the cylinder, maximum burnt product should go out, maximum fresh mixture should be inside the cylinder. So with the help of fresh mixture, if you are pushing the burnt products, then your volumetric efficiency is increasing. So it is 115. I'll be closing here. If some questions are there, I'll be taking the questions, and then we'll be meeting tomorrow only because Dr. Ramesh will be reaching somewhere afternoon. So 3 lectures we'll be having from Dr. Ramesh's side. These will be very important sessions. Lot of work. He was my guide, in fact, PhD guide. I worked with him in IIT Delhi. A wonderful knowledgeable person, particularly in experimental part is concerned. And then he joined IIT Chennai. He's working there in IIT Chennai. He was supposed to come here because weather is bad in Chandigarh. His flight couldn't landed here. So, but he'll be reaching by today evening. He'll be reaching. So tomorrow sessions, all 3 sessions will be giving to Dr. Ramesh. If any question is there, देखो कोई question है क्या? Arjot?
Yes, sir.
Please take if some questions are there.
maximum air in the combustion chamber.
Cylinder में आनी चाहिए. Yes.
Then increase the volumetric pressure.
Yes.
सर उसके लिए वाल्व इंक्रीज वाल्व साइज तो बड़ा होना चाहिए.
वाल्व के लिए जगह ही नहीं है, मैं कह रहा हूँ ना, आप लगाओगे कहाँ पे? इसके लिए क्या करते हैं, फिर सुपर चार्जिंग करते हैं, टर्बो चार्जिंग करते हैं, वो डेंसिटी बढ़ाने के लिए जो. यस.
हेलो.
यस यस.
I am from YMC University of Science and Technology, Hyderabad.
जी.
In petrol vehicle, we are adding extra premium petrol many times for a better average of the vehicle. Now, what are the changing properties like combustion or other parameters inside the flame travel by using extra premium petrol?
Actually, whatever efforts are being done, all are related to octane number. Either one is lubricating properties, another one is this octane number. Higher the octane number, even engine operation is smooth, and it is assumed up to certain limit engine efficiency is increasing. So whatever these premium fuel efforts are, basically enriching the octane number. आपका जो chemical reaction का time जो है, that will have to enhance. If severe detonation is there, even efficiency is going down up to a certain limit. If knocking is there, it is increasing the efficiency, but after that one, it decreases the engine efficiency. So cetane number in diesel engine above certain limit, if you are increasing, it will result in decrease in efficiency. But octane number, if you are increasing in petrol engine, higher the octane number, normally it is observed that thermal efficiency is increasing, and your flame propagation part, better fuel property. Saying if combustion duration is being reduced, not drastically, slightly, if combustion duration we can reduce, your pressures will be slightly higher of the cycle, your mean effective pressure will be higher, and engine output will be more, engine efficiency will be better.
Sir?
Yeah.
I am having a question regarding the combustion spark plug system.
Okay.
In the spark capacitor, and when we give potential across the capacitor, then its both cylinder will be positive and negative.
Okay.
Positive may be assume that it is earth, and negative which will be connected with the battery or secondary coil.
Okay.
So when you will be discharging or when you will be giving spark, in that case the positive part will come to zero, electricity grounded. But in the negative part we will be having some charge, and this charge will be flowing back to the circuit. And when it will be flowing back to the circuit, it will be affecting the primary current and the secondary current. So how do we control this discharge of the capacitor?
Exactly, electrically I may not be able to explain that one, but basic principle is the condenser is a reservoir. In fact, it's a storage of energy. It is when primary circuit is completed, then battery is a storage and it is grounded. When contact breaker is coming into picture, when primary circuit is getting break, when rate of change of current is there in primary circuit, then secondary winding is coming into picture. From primary to secondary, the volt jumps, and in high voltage is produced in the secondary, and condenser is coming into picture when secondary to primary, when voltage jumps, when at spark plug, when the quenching of spark is there due to lower voltage, when quenching is there, then secondary circuit becomes open. When secondary circuit becomes open, that voltage jumps to primary one, rate of change of current in primary, and that time the energy in reverse direction which is coming, it is being stored in condenser. And what I understand, even this condenser is not being used in electronic ignition system. Even without condenser, people are operating. Exactly how they are operating at higher speed, I may not be knowing up to that extent electrical part, but what we can understand from here, it's a storage device. And in primary circuit, when there is again closing of the circuit, the built up voltage, whatever we have stored into the condenser, in building up the voltage in primary circuit, it is helping. Otherwise engines are running at a very high speed. Suppose it is running at a 10,000 rpm. If 10,000 rpm it is running, in a minute 5,000 sparks will have to produce. If 5,000 sparks we are produced, and not only 5,000, if 4-cylinder engine is there, then 20,000 sparks will have to produce in 1 minute. So building up voltage in primary, again that 12 volt, that is not time available is not sufficient, it is not building up. So that time this condenser is helping for building up the voltage.
my second question is that if we have to increase the energy in per spark, then we have to either we have to increase the spark gap, or sorry, we have to increase the gap in the spark plug, or we have to increase the voltage. What we can do to increase the energy input in the cylinder per spark?
देखो स्पार्क आप स्पार्क गैप above certain limit you can't increase. If it is larger spark plug gap, then voltage won't jump. For jumping we need high voltage, because amount of air which will be available between electrodes, that quantity will be larger, and ionization of that air, it needs very high energy. But energy is limited. From primary to circuit, the energy which is jumping, either we'll have to provide some high energy ignition system, or if conventional ignition system we are using, that energy is limited, and that will have to pass across the electrodes. So अगर बहुत ज्यादा कर दिया तो आपका स्पार्क होगा ही नहीं. बहुत कम कर दिया आपने, अगर गैप कम कर दिया, तो अमाउंट ऑफ एयर फ्यूल मिक्सचर विच विल अवेलेबल बिटवीन द इलेक्ट्रोड्स, दैट क्वांटिटी विल बी वेरी स्मॉल. सो अगर कंबशन शुरू भी हो गया तो भी आपका फ्लेम प्रोपगेट नहीं हो पाएगी, बिकॉज दैट अमाउंट वेयर कंबशन हैज बीन स्टार्टेड, दैट विल बी वेरी स्मॉल. सो आप इलेक्ट्रोड गैप करके एनर्जी नहीं बढ़ा सकते. एनर्जी तो जो इनपुट दिया आपने प्राइमरी से सेकेंडरी में जंप किया, दैट इज एनर्जी ओनली. 0.8 mm विच यू आर मेंटेनिंग. उससे ज्यादा कर दिया तब भी नहीं होगा, कम कर दिया तो आपका कंबशन फिर स्टार्ट नहीं होगा. Yes.
When we use
Yes. Good afternoon. जी. 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 Yes. Lead is always available. I'm saying after 2001, when Supreme Court came into picture, when these Euro norms came into picture, after that one, the lead quantity has been reduced. Even there is a story of these Euro norms also. Euro stands for EURO. It is European. Euro means European. When this fight was going on in India, particularly this toxicity of lead, this fight was going on, Supreme Court immediately said that you stop this one, this exhaust emission should be controlled, there should be some norms, everything. So for framing norms, it need time, it need energy, it need means lot of efforts it is needed. So easiest approach for Indian industries was whatever other people are doing, whatever other countries are doing, if same we can copy. Yes, if same can copy. Suppose you are giving to your students some tutorial problems you are giving. Easiest approach for the students are that the student who is most talented, whatever he is doing, if it copy can be done. Easiest approach for the student. Same we people have done. In India we have done, but unfortunate part was their copying is not a bad thing. In fact, all the vehicles which has been manufactured in Japan or Germany or US, we people are copying. Not a single vehicle we people are having our own technology. Forget about this Tata and all small technologies. Otherwise, no technologies we are having, but we are using. Using technology itself is an innovation. There is no doubt about that one. But unfortunate part was there in 2001 when we said Euro 1 we are bringing. These were the norms which Europeans have devised in 1994. Their norms which they have imposed in 1994, those norms we have copied and we have implemented in 2001. After 7 years you are imposing the norms. Till that time lot of changes has come in the environmental conditions, and that too in India. Any rule which is applicable anywhere in the world, those rules are not universally applicable in India. Reason for that one, our population base, you see, it is not only automotive vehicle pollution. The highest pollution which we are getting, it is from our municipal solid waste. It is lying huge population base we are having. So enough methane is getting out into the atmosphere, and in that environment the norms which we are putting those norms which in European countries they have imposed in 1994. So how it can be useful here? And surprisingly, not a single vehicle manufacturing has been stopped that time. even in implementing those norms, these people have done some tricks, particularly the cycle at which engines were being tested. Again, Supreme Court came into picture. They said even the testing of the vehicle which you are doing for the purpose of measurement of these exhaust emission, the same cycle which Europeans are using, you use that cycle. Then the trouble came on the Maruti. The production of Maruti for 6 months it has been stopped. When exact cycle of European countries has been implemented, and then this lead part, because refineries are in refinery, it is not just putting lead or just putting benzene. Every process has to be changed. The cost which was being imposed on the refineries, it was too high, and refinery lobby of our country is very strong, so they have put lot of obstructions into removing lead also. So partly it has been removed from that one, so that the financial condition of those refineries can also be maintained.
There is one more question. When we use fresh air to take out exhaust gases, some air may also go out with it, which may cause loss in efficiency. So, sir, does engine size have any effect on combustion parameters, such as after burning and ignition lag?
Actually, no, this philosophy, still I am not agreeing in the case of four-stroke engine, that helping exhaust gases to go out with the help of fresh mixture. That this philosophy, still it is not clear. At least to me it is not clear. Reason for that one is, when exhaust valve is in open position, when exhaust is going on, pressure inside the cylinder is higher than atmospheric. Yes, and before completion of the exhaust, we have opened up the inlet valve. I'm saying suction is always below atmospheric. Then only mixture, fresh mixture will be entering into the cylinder. If pressure inside the cylinder will be lower than atmospheric pressure, then only fresh mixture will be coming into that one. So when burnt products were going out, which were having pressure slightly higher than atmospheric, and at that particular juncture we have opened up the inlet valve, which is allowing the mixture to go into the cylinder lower than atmospheric. How lower than atmospheric pressure can help the burnt products to go out which are having higher pressure? So most of the times with overlapping, some of the burnt products, there are possibility they can go into the intake manifold. In place of pushing the burnt products go out, because their pressures are higher, the suction pressure is lower, so burnt products may enter into the intake manifold, and particularly at the time of idling, when RPM is quite low, lot of burnt mixtures are entering into the intake manifold. But there is no question of going out this fresh mixture with exhaust, because their pressure is lower. So forget about in four-stroke engine that fresh mixture will be going out. I am afraid that these burnt products are going back into the intake manifold. In two-stroke engine this happens. In two-stroke engine, from crankcase we are supplying fresh mixture into the cylinder which is higher than atmospheric, and that time your exhaust port is also open, so that time your fresh mixture is going out because its pressure is higher than atmospheric. Any other question?
Sir, they are asking for PPT.
We'll send. Don't worry. We'll give complete lecture. Actually, I couldn't complete my lecture. Sometimes tomorrow I may get. I'll complete.
Sir, YouTube पे भी lectures.
That will be available. YouTube, it is available. PPT separately will be sending to them.
There is another question.
Yes.
Sir, it is heard that railway diesel engines are not switched off when in either state. Why is it so?
Again, repeat.
Sir, it is heard that railway diesel engines are not switched off while in either state. Why is it so?
Actually, starting of the diesel engines, very large size engines are there. More than 1000 kilowatt engines are there. They are starting because they are diesel engines. Starting is very difficult. With compressed air, they are starting. So once it has been started, again switching off and again starting, it's a very daunting task. It's a difficult task. And I'm saying in idling, air fuel mixture is very lean in diesel engines. Around 70, 75, 80 we are having. So fuel consumption is quite low when it is in idling state. So again and again switching off, switching on is not advisable in railway engines.
Yes, I am Dr. Mangla from YMC University of Science and Technology. I am asking a general question about the engines.
Ji.
See, yesterday itself, some good speaker was saying that if you want to simplify a design, or if you want to improve upon the design, go the simplest way. Let us not catch the nose the other way around.
Same way here, see, we are designing all these engines for power, but nature has given the horse as the best engine, and which doesn't pollute at all. And so why don't we go back to that best engine, and it has all safety inbuilt in itself.
क्या नाम है आपका डॉक्टर डॉक्टर निरंजन देयर इज ए साइकिल ऑफ ऑल दिस सिस्टम ये करीब अपने 12,000 का साइकिल है जैसे भी अपनी चाहे द्वापर युग हो चाहे त्रेता हो चाहे कलयुग हो ये 12,000 का साइकिल है आपका 12,000 के साइकिल में आपकी सारी चीजें आएंगी आपके घोड़े भी आएंगे आपके इंजन्स भी आएंगे आपकी कारें भी आएगी आपकी पायलट ट्रेन्स भी आएंगी एवरीथिंग विल बी कमिंग बट नेचर हैज टू हैव बैलेंस अगर बैलेंस नहीं करोगे द फॉग विच इज इन डेली एवरी डे वी आर ऑब्जर्विंग हमें लगता है कि ये फॉग आ गया है आप में धुंध आ गई इट इज नॉट फॉग इट इज स्मोक दिस केमिकल्स the hydrocarbons oxides of nitrogen particulate matters in the presence of sun it is becoming smoke it's a chemical long back in California thousands of people died then in London smoke again lakhs of people died in Bhopal tragedy we are remembering we were still remembering same tragedy will be in Delhi that's my prediction it will be तो ये सारी की सारी जब तक अति किसी चीज की नहीं होगी तब तक ये चीजें चेंज नहीं होगी our best friend was animal particularly in Indian conditions where 70% population is in India no diesel no petrol nothing was needed everyone was healthy now from Punjab from Batinda Fazilka one train leads to Bikaner they are having a huge research cancer research center 300 new patients are entering into Bikaner daily and the name of train is cancer train so जब पशुओं से था तो न तो ये कैंसर थी न कैंसर ट्रेन था न दवाइयां थी न केमिकल थे न फर्टिलाइजर थे न डीजल का धुआं था न पेट्रोल का था इट इज इट्स ए साइकिल एंड दैट साइकिल हैज टू बी कंप्लीटेड we'll have to go everyone has to go we'll have to reach that destination हमारी सबकी ये इच्छाएं पूरी होंगी
Thank you very much.
okay bye
Sir, what is the effect of engine size of combustion parameters?
engine size if I'm saying in terms of diameter engine size in terms of diameter we are saying in the case of petrol engine we want the diameter should be as small as possible so that flame has to travel lesser distance if it is traveling more distance chances of auto ignition of end part will be more because more time is required to flame to reach to end portion so in the case of petrol engine our efforts are to reduce the diameter to avoid knocking in contrary to this one in the case of diesel engines we want largest diameter engines reason for that one is the sprays which are coming out from the injectors yes fuel is being sprayed we never want that spray should touch to metallic part of the cylinder if it is going on the metallic part the fuel which has touched to the cylinder walls it will be mixing with lubricating oil even it can go into the crankcase and unburnt it will remain we never want that spray should touch to any metallic component of the cylinder so larger the size larger the diameter chances of touching those sprays to the cylinder walls it will be minimum so in the case of diesel engine always efforts are to have larger diameter engines in the case of petrol engine the diameter of the engine should be small as possible no question so okay if no question is there I'll extend my sincere thanks to every university who are participating I hope this 5 days program will be quite useful my special thanks to Dr. Seema alone I think participant from Vanastri she was saying so it's a great opportunity for me also to interact you people and many questions are coming even in between also after closure of this program if you people are having any queries related to this subject particular subject internal combustion engines I'm ready anytime wherever you'll be sending your queries I'm ready to reply for all of these queries thank you very much